Hello everyone, thanks for tuning in. This is the overview of what we're going to do when we are building a simple calculator in Swift. So let me just go through all the sessions that we have and what exactly you're going to learn. So in the first session, we will learn a lot about how to set up your UI. You will learn about views and auto layout. You will learn about how you can define your UI in a way that it works on all the different sizes of devices. We will start with creating a new Xcode project, and after that, we will simply build the whole UI for the calculator to come. In session 2, you will learn about the basics of Swift. So what is a variable? What is a constant? What are control structures, loops, if statements? What are objects? What are properties, methods, and all of this? You will get this covered here in the basics of Swift. After you hit the ground running with your new basic Swift skills, we will talk about how we will store our mathematical terms that users are typing into the calculator in Swift. And that's important for session number 3, because in session number 3 we will use these terms to calculate things. We will put these into a calculator logic, and this logic will understand our terms and print out the right solution. And we will also take into account how we handle the different kind of operators in mathematical terms, like that multiplication and division should be handled and calculated first before we can calculate plus and minus. And in session 4 and 5, we will just connect everything. We will use our UI that we built in session 1 and connect it to our little calculator logic, and this way end up with a finished project, a finished simple calculator made in Swift using Xcode. And yeah, so if you think that this is something for you, if you're a beginner in Swift, join me, and yeah, I see you soon. Having a great day. Hello, welcome to creating a simple calculator in Swift. So, I think we are on time. It's 22 o'clock my time, so I think 2 p.m. EST, I guess. Yeah, to introduce myself, I'm Daniel. I'm streaming from Hamburg in Germany, and today we're gonna start our project. I think the current curriculum may not be possible because I think that we have to split session 2 in actually to be 2 separate sessions, but more on that later. The slides, I will do a little presentation up front in front of every streaming to give you the basic idea what we're going to do and give you some overarching and overall concepts, so that you find your way better around when we are in Xcode. The slides are available for download. Currently there's only the slides for this session, but I'll upload the slides for the next session and the program we will create together today after this stream, and so you have it on your machine as well. It would be good if you have Xcode 9 or 8 already installed on your machine, so if you want to follow along. Otherwise you can look the video later or follow on your own memory, do everything yourself later on if you like to. What else? Something I want to say. I don't know. Maybe we just get started. Yeah, one more thing. I'm using Xcode 9, so a couple of things that we're going to talk about today are new in Xcode 9. I will point these out explicitly, so you know, if you use Xcode 8 still, what these points are. Okay. Session number 1, defining the user interface. We are going to do a little bit talking about what are views and auto layout. After that, we will create a new Xcode project, and then we will dive into creating our UI for the simple calculator. If there are questions, please feel free to ask. When I look over there, it's because I look at the chat window to check if there are any questions. Don't. Hello, welcome. It's Sunday again, and we will be programming a simple calculator in Swift. So, we have approximately 1 hour to go over some basic concepts in Swift and start implementing a representation for mathematical terms using Swift. And before we start with session 2, let me see. It is working actually. Okay, so before we start with how to store math in Swift, I'd like to go over the agenda today. So we will talk a little bit about what a calculator actually does. So by dissecting how a calculator works, we will find ourselves deduct ourselves a way to represent this logic inside of Swift, and so that we can implement that. And before we implement that, and because this is a totally beginner's stream, I will go over some basic concepts regarding the Swift programming language, and after that we will actually create our representation. So, just see. Before I do this, so that's actually what I want to do before, is to do a little bit of a recap what we did in session 1. So in session 1 we created our UI for the calculator, and we learned that views are the fundamental building block of our UI. That views are hierarchical, so which means that views are nested inside of other views, which can be itself be nested in another view. So you have a view and a view and a view and a view, and so on. And that the frame of a view is the name for its position and size inside of its super view. And we learned about auto layout, which helps us to position these views inside of its super view using the constraints or a rule-based systems, which is called auto layout, which uses rules which are named constraints to actually position or calculate the position of views inside of a super view. Just a quick reminder, auto layout is really important if you want to have an app which is adaptable to different screen sizes, which can occur between different versions of the iPhone, or if you want your app to be running on the iPad or an iPhone. If you want your app to be running on the iPhone and iPad. Mark Miller, hi, nice to see you. So the room is filling. Glad to see that. So now, Polo Donald, you're not late. I just recapped what we did last week, and now I will go over the agenda, what we do today again, so everybody which is with me right now can follow. So what we do first is just talk about what a calculator is actually doing. So we will dissecting the behavior of a calculator in order to find ourselves the needed clues and to represent a math term in Swift, and we'll actually implement a representation for that in this session. In the next session, just a little bit of a spoiler, we will actually calculate these representations so that we have the full logic of a view in of a calculator in Swift. So I hope the stream is working, the music is not too loud, and you can understand me clearly. So if you don't, please let me know. After we talked about the basic concepts of the calculator, I will do a quick introduction to the Swift programming language. I won't cover all of Swift, of course. I will go from the basics, since this is a beginner's stream, and teach you the main stuff that we will need to implement our representation, and later the calculator logic. And after that we will actually create this. Okay, calculator 101. So when you type in a values, so like 1, 2, 3, 4, you after that select an operator. Operators are like divided by, multiplied by, minus plus, or the plus minus operator, or the percent operator. So basically all the 2 top buttons and the 4 buttons up from the equal sign are all our operators that we have right now in the calculator. So we have 2 different kinds of operators on a calculator. There are unary operators, which give us an instant result. Unary being a fancy word that there is only one operand or parameter or one number that is actually used to calculate the result. So for instance, the plus minus operator makes a minus 5 and gives the result instantly back. Or we have binary operators which are taking the number you entered before you selected the operator and the number after you selected the operator, and will calculate the result. So for instance, the multiplied by operator is a binary operator. So let's do a little bit of example here. So you type in 1, 2, 3, 4, you hit the plus minus operator, you get a minus 1, 2, 3, 4. Amazing. So let's do a second example. I just give you some examples here to actually find the clues and in how we can represent this later. So 1, 2, 3, 4 is typed in. We hit plus, type in 103, hit the equal sign. So the equal sign is the last button we hit before we get the result, and we get 1337. Calculator example 3. You type in 12. You hit plus. You type in 265. You hit multiply by. You type 5. Hit the equal sign, and the result should be 1337. Another example. You type 5. hit the multiply by button, type 265, hit the plus button, type in 12, hit equal, and the result is the same, 1334. 1337. And this should be equal, hopefully. Why am I stressing this? Because if you look at the example on the left side, we are hitting the plus before the multiplied. And in the example on the right side, we are using the multiply by operator first, and after that the plus operator. In both cases, the result should be the same, because we have to use the operator precedence rule, which means that we have to calculate the multiplication before we do any addition or subtraction. So to be a little bit more formal, we have two different kinds of operators here, of binary operators. We have the ones that are using multiplication and division, so multiplicative operators, and we have addition and subtraction, which I call the additive operators. So we have to keep this in mind so that we have this resembled in our representation later. So this is the last calculator example, I promise. You type in 5, you hit times by or multiplied by 265, hit equal, which is 1325. After that, you hit 5, type in 12, hit equal again. You get 1337. So we are reusing the result from the last calculation to calculate our next calculation. That's important as well. That's a typical behavior of a calculator. So what are our main takeaways here? So just to recap a little bit and to give you the main clues I want you to get from this examples here. So first, we always enter a number. We can't do anything with our operators unless we enter a number, or we want to use the default 0, which is the starting value of our calculator after clearing the calculator or starting it up. So the entering of a number ends when we touch an operator. So this is how we can distinguish between typing on the numbers pad and hitting an operator will start the next number, because we have to append each digit of the number to get the final number, which we use for our calculations as the operand. After hitting the equal, we can reuse the result just by using an operator again after that, unary or binary. And we have to take into account, and this is really important, operator precedence. Unary is stronger than multiplicative. You know what I mean? This middle word there, and which is stronger again than additive. So we have to evaluate the unary before the multiplicative and the additive operators. So let's do this with a term that we can represent as this one and dissect this so we get an idea of the parts of an equation. So we can dissect this into two different classes of items, or I call them token, inside of this equation. We have the operands, or the numbers in green here, and we have the operators, the percent sign, the multiply by, plus, and multiply again. So how do we evaluate such a term with taking account the operator order or operator precedence? So we will first just evaluate the unary operator, because that's the strongly binded, and we go from left to right. This is really important for the next session. I will recap this again, but this is important for the next session to understand our evaluating the terms. But we need to understand how to evaluate them so that we can now build the representation for evaluating it later. So first the unary, which makes a 10% to a 0.01. After that we will evaluate the multiplication, getting a 12 for that. After that we have to jump over the additive operator, the addition here, and evaluate the second multiplication before we can finally evaluate the whole equation and the last addition and additive operator, getting the final result. So when we think about that, we can now look at the different elements that we have in our equation and put them in some kind of a hierarchy. So we have the operands, basically the numbers in an equation, and we have the operators. The operators, we have learned, we can distinguish into two groups. Binary operators taking two inputs, and unary operators taking one input. The binary operator we have to distinguish again in order to have a sense of when to evaluate which of these. We have the multiplicative operators, which gets evaluated before the additive operators. And to have a full tree of a full hierarchy, we need one top element, and that's like, you can name this anything you want. It's an item, it's an element, it's whatever. I use this term token here because it's a term from the computer science domain, which is basically defining one piece of a series of different tokens which gets evaluated in a parser. These may be some fancy words here, but I will explain this in the next session. So bear with me here. We call this token. And operands and operators are token. So this is basically our representation hierarchy of our mathematical terms. So, are there any questions regarding this deduction, this representation hierarchy so far? Because we will use this as a blueprint for our programming today, which we do later after I introduce the basic concepts. Okay, I will go on. If there are no questions. Operands. Okay, can you explain me once more the operands? Of course, I can do. Operands are basically just the numbers. So if you have an equation which is 5 plus 2, you have two operands and one operator. The operator is the plus, and the operands is the stuff the operator works on. So the 5 and the 2. So 5 is an operand followed by one operator, the stuff that actually does something, the plus, followed by another operand. That are the operands. So and the operators are binary and unary. Unary meaning that the operator needs only one operand, whereas a binary operator needs two inputs, meaning two operands, like our example 5 plus 2. So I hope this makes it a little bit more clear. If not, just ask again. Perfect. So, short introduction to Swift. We will do this in a playground. The playground I will write up here and will give different examples for different stuff we can do with Swift. And after we are done here, I will put these two playgrounds with these slides into the project files that you can find under this stream here. So, okay, let's go. Short introduction to Swift. So this is our playground. A playground is basically a special Xcode project where we can write Swift, and on this side here we can see the evaluation of the code. So I just clear this now and we'll start fresh. So the first thing that we have to do is to import our commands, our Swift commands. There are some really basic Swift commands which are all bundled in the foundation module. The module, you can just think of a collection of different functions and variables, and data types and all that. That will make more sense after we are done with this, but just think of a module as a collection of reusable stuff you can reuse in projects of Swift. And you can import a module by writing import, and we use import foundation. And foundation is basically the Swift foundation library, which gives us the foundation to actually use Swift, basically. So we will start with an introduction to storing data. So programming is about getting data in and getting data out. That's as simple as it is. You get some kind of data in, you manipulate it, hopefully in the right way, and you get it out in some way. So getting data out is actually can be as simple as reading from whatever, a label, reading from a file, reading from other data in the program, and getting it out is like writing it on the screen or giving it to another part of the program, writing it to a file, everything that we do. So I will go with two different concepts here. We can store data in a variable. So a variable is basically a container for data. So like a box where you can put stuff in and get it out and put different stuff in and whatever. So when we want to declare a variable, we write var, short for variable, give it a name like a, and give it a value. So real quick, this variable, this box a, now stores this number. This is the first stuff you learn. Variables. Variables you can use, and you can change variables. So I can go in here, and change the value by just setting it equal to a new value, like 1, 2, 3, 4. Now a has the value 1, 2, 3, 4. When I now write simply a, I will see here the value, because everything is evaluated. Evaluated meaning the value of this expression, this type of code is deducted and will be shown on this side here. So the value of a is now 1, 2, 3, 4, whereas if I delete this, it is 1, 3, 3, 7. So that's a variable. There's a different kind of storing data, which is in constants. Constants, as the name is saying, is like a box where you put something in, but you never can get it out or delete it, or yeah, you can actually delete it, but you can't change it. So if you put something into this box of a constant, it's like it's chiseled in stone. So let b equal to 1336. So 1336. So I think I have to speed up a little. I think this is really basic stuff. So a constant is actually not changeable. So if I try to do this 1 2 3 4 and change the value of a constant, I get this cannot assign to value b is a let constant. And actually, if I hit this here, I can fix this by change let to var. So if I do this, this var change, this let changes to var. So, but this should be a let, and I get it back and I correct this. I can't change it. So, question: which would you recommend to use? So I basically think you mean variables versus constants. So I would suggest that you use constants as much as possible. So if you don't want to change the value, or you don't intend to change it, just make it a constant value, and this will make your life a lot easier. And this is a discussion about mutability and immutability in data. So I just dropped this here. So plain suggestion: make everything const as much as you can. Okay, so we have now data, and we know how to save it and how to put it into the program. So now let's talk about different data types. Data types are actually like the different sizes of boxes you get, the different flavors of boxes you can put your variables in. So we used, so we have different kind of data types here. We have data types which are called strings, and we can put text into them. So a string is a string of characters. So we have it's a text. We have integer values, basically numbers without decimal places. So int 1, int 2, int 3. We can have values that are called double values. I just named these variables according to the data type that is stored in there. I could name them any way I want, but this should just make it more easily to grasp for you. So I can put in a double value, basically a number with decimal places. And there is another type of values with decimal places. It's called float. And I can just put something like this in there. Float. So this looks different than this here, because I now denoted the data type explicitly. After this colon here, I write which kind of box I want. So I want a float box. Here, the type is implicit, which means Swift is looking at what you want to put into the box and gives you the right box which fits it. So, as an example, if I have this variable here, I call this name, and I make it this is a string. My name is Daniel, so I put it in here. And when I now want to put in an integer in there, for instance, name is equal to 1323, I will now get an error which tells me cannot assign value of type int to type string. So basically the box for my strings is not fitting my numbers. So how does it know that it's a string? Because the first thing I put into the box or in this variable was a string. After that it will always be a string. So variables here in Swift are strictly typed, which means if they have a type, it can't change anymore. So name will always be a string. By writing this here, float, colon float, this here is interpreted as a float. The problem is this, if I just write this here, Swift by default uses double as a data type for numbers with decimal places, and here I tell Swift to explicitly use the float. Float and double are both data types or boxes for decimal numbers with decimal places. Float has a little bit less accuracy when it comes to or has half of the accuracy when it comes to number of decimal places. This is really technical. I just dropped this here. If you want to read up on it, just feel free to search for floating point numbers. Okay, there's one more variable type, data type I want to talk about. It's a Boolean data type. Booleans are basically a data type which can only hold two values, which is true or false, basically 1 or 0, yes or no. So this keyword true is basically the one, the true statement, and by writing this, Swift knows I will use a bool. The other stuff you can put in there is false. Okay, let's leave this true. And okay. Let's talk. If there are any questions, just feel free to ask. Otherwise, I will go over to operators. So operators are basically like on a calculator. Each data type has different operators you can use on it. So let's start with a number and initialize it with 0.0. Then this is basically a double value because we have this decimal place here, which represents the number 0.0. We can now change number by using number and adding 10. So this is the operator, plus operator. Uses this operand and this operand. And now we have number has the value 10. Because we calculated number plus 10 and put it back into the variable number. Easy peasy. We can use a other operator which is minus 8 equals 2. We can use multiplication times 100. We can use division. By 30 gives us some 44, I think. Or 6.666, of course. And we can use negate, a negate operator. Just by writing a minus in front of a number variable, this number will be the negative number of number. So number is now minus 66666. And we can use, of course, we can calculate the square of a number by using number multiplied by number. Yes, just by using operators. So operators basically are this little thingies here between two data types. They don't have to be the same data type. There are like instances where it isn't, because like this here, this is a box here is a double data type. This here is an integer. And there is a operator defined that tells us, okay, if you have a double and you multiply it by an integer, it works. So this is operator stuff. There are more operators. You can use operators not only on numbers. You can use operators on strings as well. So if you write first name, so Matthias, and let last name, so we have two constants, because persons rarely change their name, right? Maxwell, Matthias Maxwell. We can use operators to calculate the full name. So the full name is basically the first name a space between it and the last name. So, full name, come on, print out Matthias Maxwell. So there are operators which are defined on strings, there are operators which are defined on numbers, floats, whatever. You can use your own data types, we'll talk about this later, and define operators on them as well. Okay, there's an alternative way to doing this here. So instead of writing this, I just comment this out. The comment is this slashes in front of the line of text, which indicates that the Xcode, the compiler, should not worry about it. So it's just for us humans to make us some notes in code. So by like I did here, where I give it this little headlines here, I use this double slash to just tell the compiler to ignore this for now. So I can show you another way of doing this. The other way is you can use a string by starting this quotes, backslash, open and close bracket, and write in there first name, do a space, brackets, last name. So by using this construct here, like this backslash, bracket, bracket, you can put any variable or constant in there. So this is like you can use variables in your string to replace them. This is called string extrapolation, and in this case it will give us the same result. Come on, calculate it. Here we go, Matthias Maxwell. Good. Let's go over. If there are no questions, let's go over to functions. Functions are reusable fragments of code. I just say it. If you don't understand it now, you will understand later. Reusable fragments of code that you can use in your code over and over. So there's a question, Starlord 91. I didn't quite understand strings. Okay, strings is nothing else than a fancy word for text or a list of characters. So if you form a word and you write a word, you write one character after another, and a string is nothing else but storing this list of, or this string of characters. So like first name Matthias is nothing else like the capital M followed by a lowercase a thias, and this is the value. So string is a type of data that holds a list of characters. Nothing more, nothing less. I hope that makes it a little bit clearer. So there's nothing magical about it. And the plus operator on strings is actually appending one string after another string. So what I did here, I just put this back in here. I used the variable first name plus the string, which is just a empty space, plus last name. So I appended this string, and this string, and put it into the variable full name, which evaluates to Matthias Maxwell. Okay, functions. So functions are reusable pieces of code, which you give a name, and then you can put in some variables which it uses to give you a result, basically. So these values you put into a function are called parameters. So let's do something. We calculated the square of a number by using number times number, but there is actually a function for that. So let's square b pow of number, comma 2. So pow is short for power. So we calculate the power of number the second to 2. So number to the power of 2 is the square. So number by number. So this is the name of the function, power, and these are the inputs that go in there to help the function calculate what you want it to calculate. The first parameter is the number you want to power, and this is the power you want to give it. So like number to the power of 2, you give the first parameter number and the second 2. So power 2 to 3 is power of 2 to the power of 3 is 8. Like you see here evaluated. To the power of 4, 16, power of 5, 32. Basically this is short for 2 times 2 times 2 times 2 times 2. Correct? Yes. So this is one function. We have another function. So root is sqrt, short for square root of square, which gives us back our 4.44445. When you look here, number's last value was 4444445. We powered it again, getting 1975. Getting the square root back gives us the value back. So this is just to give you two examples of functions. So there are a lot of functions in Swift. So like a ton of functions in every programming language. But this should just gives you the basic understanding. A function has a name, it has different parameters, and it has a return value. The return value is basically what this variable is assigned to. What this variable gets assigned. So if I now, like if I hold Alt, the alternative key, and hover over these functions, I can click and get a definition of the function or declaration. So we have a function func named power with two parameters of type double, returning, this is the little arrow here, double. Okay, and with square root, it's function named square root gets one double and returns a double. Okay, hope that is clear. It's really fast here. I just have to go through this really quick because we have to have a lot of ground to cover here, and it's already 11, so it will be a little bit longer today, I guess. Hope that's okay for you. So let's go over to methods. So methods is another name, or is a name for functions inside of data types. So now we're getting stuff together here. So we have functions, which is just reusable code, free floating in this space of our program. We can use it everywhere. And methods are actually functions inside of a data type. So data types can define functions that are used with them, on them, or so which are coupled or moduled inside of them. So let's say it to that. You will see what I mean. So we have our variable first name here. Okay, first name evaluated to Matthias. When you hit the dot, you will get a list of functions. A list of methods that this data type offers you to manipulate it, to get to manipulate it or get different informations from it. So there's one method that is called uppercased. So this is uppercased. If I write that, this will evaluate to Matthias all in capitals. So if I look at the function description here, or the method description, you see that func uppercase returns another string. Returns an uppercase version of the string referencing first name. So first name is the string. And the following example transforms a string to uppercase letters. So cafe, like this green tea icon, becomes cafe with big letters or capital letters, uppercase letters. Okay, so methods. That is really quick. Let's go on. We will use methods later with our own stuff, so we will all use a little of this with our own representation, but this is just to give you a little of glimpse here of what we are going to do. So, Boolean expressions. Boolean expressions. So Boolean expressions. It's basically we talked about this one data type which can only hold true and false, right? So Boolean expressions are used to ask specific questions in the program. Let's put it this way, which are answered by either it's true or it's false. So let's see. We have our variable first name, which is now, it's still Matthias. So there's one little thing I want to add to this methods thing here. There are two types of methods. The first kind is non-mutating, and the second kind is mutating. So uppercase is a non-mutating method, which means it doesn't change the value of first name. So first name is a constant, so it can't change the value, but it wouldn't do it even if it was a variable, because uppercase is non-mutating. It takes the value of first name, uppercase every character in the string, and returns the new value to the calling program, in this case our playground. So, but it doesn't actually change the value of first name. That is why first name down here in line 43 is still Matthias, only with a capital M. I hope that makes sense. So Boolean expressions, there are different Boolean expressions. Double equal means, is it equal to whatever we write next? Is first name equal to Daniel? Let's ask the program. Oh, false. Yeah, because it's equal to Matthias. First name equal to Matthias. True. Is first name equal to first name? Of course, it should be, right? So that is the question, is it equal? You can negate this question. Is first name not equal to Daniel? Sorry. First name. Of course, it's not equal to Daniel because it's Matthias. So another example, is first name not equal to first name uppercase? True again, because first name with a capital M is not equal to first name with all capital. Okay, so then there is something like you can ask the question, is something less than or bigger than? So let's try something more fancy. Let's say, is A less than B? True. Is ABC less than AB. False. But it's less than ABD. True. So it works on strings as well, by looking at the alphabet and counting, like seeing if the letters in a word are actually less than in the order of the alphabet than the other word. So bigger than. So let's check. We can do this with numbers as well, of course. Is number bigger than root? False. Because let's remind ourselves, number has the value 444. Root has the same value. So it's not bigger, it's equal. So let's try. Is it equal? True. Is it equal or bigger or equal? Of course, still true. So we have different kinds here again, just to give it a little bit of a... So is root smaller or equal 45? True. Okay, so we have different kind of Boolean expressions, just to say equal, unequal, less, bigger than, less or equal, bigger or equal. So that are some Boolean expressions we can use. There are a couple of more stuff that evaluates just to true and false, but this is like the basic stuff you need to know. Okay, any questions on Boolean expressions? Good. Now we come to something that is a little bit more special in Swift, that is optionals. Optionals is a special kind of data type flavor, I would say. So every data type can be an optional of some data type. So, for example, we can have an optional string, we can have an optional integer value, we can have an optional float value. Optional just means maybe it's an int or it's not nothing. So it can be optional, can have two different states. Either it's nil, nothing, not initialized, not filled, nil, or it can be some of whatever data type it is. So they are not necessary. What do you mean? You mean optionals are not necessary. You mean that the data type is defining that the value is not necessary. I think, yeah, that's basically how you can put it. So if you define a variable, maybe number, to be of type int question mark. Int question mark is basically telling that it's maybe an int. It can be nil as well. It can be maybe an int or it can be nil. So, and this is default initialized with nil. So now it's nothing. It's not an int. But if you put in a maybe number and put it to 3, now it's 3. So this is important because we sometimes want to have empty boxes, but in Swift everything has to get an initial value. So if you have a variable, you have to define the initial value at some point. And in case, let's make an example. If you have integer and you want to store like temperatures, then 0 is an actually valid value for a temperature in Celsius, for instance. And using 0 in your program as not defined, or 0 as being a not set temperature level, it's actually not the right way to do, because 0 is a perfectly fine value for a temperature. So the better way is to have a variable of type optional int and set it to nil when you want to represent a not yet set temperature in your program. For instance, if you program a heating system, you want to have this extra value of not set. So this is what optional is about. Okay. Optional gives you some little tricky stuff here. And we set maybe number. So you can use the Boolean expressions to check if it is nil. Maybe number equal nil gives you a false, hopefully. Yeah, because we set it to 3 beforehand. And you can do something else here, which is pretty interesting. So if you have a value and you don't know if it's set or not, and you don't care actually, because you want to either use this value if it's set or to use some other default value, you can write the following. Maybe number question mark, and let's say 1, 2, 3. So this expression here is called a optional monad. So this is either maybe number if it's not nil, so if it has a value, or it will take this default value here. So now in our program here in line 64, we set maybe number to 3. So maybe number question mark 1, 2, 3 evaluates to be 3. If I would now say set maybe number to be nil, not set, empty, whatever you want to call it, and evaluate this expression here again, now it evaluates to 1, 2, 3. So this expression has the data type of int, not int optional. This is int optional, but by appending this question mark, we give the program a way to react to a not set integer and use the default value, which makes the whole expression to be of type int. So this is really useful in many cases. You will see when we use it, but we won't use it today, but I want you to be a little bit aware of this possibility when you work with optionals. Okay, no questions. We go over to collections. Okay, collections are basically, and we are not talking about collections in general here, let's be more specific, we talk about arrays. So, array or list. An array, or another name for it is a list, is a container which stores multiple boxes in a row. But each of these boxes needs to have the same kind of style, so the same data type. An array or a list stores a list of data of the same data. So it gives us the number of elements in the list, 6. When we do numbers first, we get the first element of the list, which is 1. Numbers of last is 6. When you look at this, so just a little side note here, when you look at this declaration here, what first actually is, it's returning and int optional. Why is that? Because if we define an empty list like this, oh, okay, that was, let's restart Xcode. It's okay if it crashes sometimes. So, an empty list. You do this like, you can do it like this. So you say the explicit type is list of int with a colon. You say the explicit type of the variable and make it like this, like by not putting numbers between the square brackets. You say it's empty. When I now go to empty and call first, there is actually no first element in the list. So this returns nil. Hopefully soon, because it's currently trying to launch the simulator. Let's see when it will grab, how long it will take it. I think. Just a little bit of waiting. So if there are questions, okay, here we are. So you see, empty.first returns nil. Okay, so that's why that's just to make the full circle here, and that's why this first returns an int optional. That's another good example why optionals are necessary in a programming language. Okay, let's put this away here. Let's do some more operators or stuff on. So there's something that is called subscripts. And subscripts in collections actually allow you to pinpoint a certain element and get it. So instead of just going from first and last, you can write numbers, square brackets, 1, which gives you the second object. The second, because they are indexed starting with 0. Square brackets 0 of a collection gives you the first element of the list, whereas 1 gives you the second, and so on. 3 gives you the 3 gives you the fourth, or 2 gives you the third. 2 gives you the third element. So you can use subscripts a little bit more fancy. You can define ranges in the subscripts. So you can say in square brackets, give me element 1, 2, 3. Now we will get the second element to the fourth element. Dot, dot, dot. It's a little bit slow right now. 2, 3, 4. 2, 3, 4. So yeah, that works. This is called an including range. So the first element and the last element is included, whereas there's an excluding range, which you denote with a less than sign instead of a third dot, which only gives you up to the fourth element. So the fourth element is not included in the range anymore. 2, 3, 4, and 2, 3 if you don't include the fourth element. If you do this, it's actually the same. You can do this with, you can check this with Boolean expressions as well. Gives you true, perfect. Okay, what else can we do with collections? And this is actually something we will use today, so I will go on this a little bit deeper. So let's do something else. Let name components be a list of strings. George R Martin. So these are different strings in the list, like the first name, the first middle name, the second middle name, initials, and the last name. So we can use methods on the list as well, and they have a method here which is called joined. Name components joined, which gives you these elements here all concatenated together. So George R. Martin gets George R. Martin in one string without any space. But luckily there's a parameter, like here, joined takes a parameter separator string. And when we put in a space in here, we will now see, after this has, yeah, here we go, George space R dot space R dot Martin. So this here is a parameter as well. As you see, like with our pow function or square root functions, we put in parameters to this functions. We have this here too, but this is a named parameter. There's a name in front of it, which is in front of the column. This is just styling, so you can decide if you write your own functions and method if you want to have that. If you look at the function declaration here, you can just alt click on it. You have the keyword func to define your own function, name it, name the operator, the parameter, colon, data type, and give it a default value if we want as well. So this is just, I dropped this here, we'll do this later, but this is now just to give you an idea. Whereas when you don't want to name your parameter and have the caller of the function you want the call of the function to write less, you can use a underscore, and this will leaves out the name parameter. Okay, good. So this is actually how you use lists of data and what you can do with it and how it ties into our other concepts of methods and all of that. Oh, thank you very much. I'm glad you can follow and get something out of this here. Good. We have one more. Yeah, we have two big things which I have to cover here before we will do a little break, and we will then go over to implement our representation. This will take a little longer than I hoped. I was asked to keep it under 1 hour, but yeah, this is not happening today. I hope you are not too mad with me, but let's go on. The next thing we want to talk about is control flow. So now that we have done a lot with data, we defined data, we put data in variables or constants, we used functions and method to mess around with this data, we even created lists of data. We don't have a program yet. So a program actually needs some kind of flow. So data comes in, we mess with it in different ways depending on what data is coming in. We do different stuff and put it out. So for that we need control flow. And we'll go over two control flow constructs. It's a loop, to be more precise, it's a for in loop and an if else statement. So let's go with the for loop. So we have our array here, which we defined earlier. We will now see how we can program a loop over all the over all the elements in this list. And this is pretty simple. We just say for number in numbers. So I think maybe this, no, it works. Okay, so this means for number in numbers, do this what's in the curly brackets. And we will just print the numbers out and we will square the numbers. So we will use our function pow to square the number. So putting in the number to the power of 2 gives us the okay. There's something else I have to do here. Okay, let's talk about this real quick. So sometimes you have data which comes in one flavor, but you need it to be in something else. For instance, here we have the problem that number is of type int because our list contains ints. Pow wants to have double values. So an int and double are two different data types. To convert one data type into another, we can use double and put in the number. So number becomes a double, which is used in power of 2, and this is executed. So you see here, it's executed 6 times. This one here is executed 6 times because there are 6 elements in our list. So you can plot this here, which is pretty cool, but yeah, not really what I needed, but it's interesting. If you look at it, 1 squared is actually 1, then you get 4, you get 9, 16, 25, and 36, which is exactly the squares of this one here. Don't worry, you don't get this. This is just playground magic here. You don't get this in Xcode. So what we can do to see the values in the log down here, we have this log window here. We can use the print command. Print basically means print it into the log. Print. So we just use it like this. So this is actually a little interesting here because this is really nested. We nested functions inside of functions. So we first have this conversion here. So converting number to double. This goes in as a parameter into our pow function. And the result of this gets into our print function. Okay? And print is actually printing out the values, the square values of our list. So this is for number in numbers. So for every element which we call in our loop number in the list of numbers. So I hope that makes sense. And we will extend this now and use a if-else statement here. And we learn a new operator, we learn the modulo operator, and we use our Boolean expressions for that as well. So everything ties in together right now. And I hope you, if you could follow along, that you get a good understanding of how this programming actually works here. So I give you a little bit of a. We do this step by step. So if an if statement is basically like asking a question with the Boolean expressions, which I told you about. Is this equal? Is this whatever? So we ask a question. And this is either true or false. And an if statement is like, if true, print do this. Oh, there's one. Come on. Okay, so every time we are now doing this number loop, we're also doing this, because we're saying if true, true is of course, we do this. So an if statement, so just bear with me a little bit. If that looks a little bit confusing, I get it, but I have a plan here. So else is like if it's not true. So if this would be false, better do this. So we run this. Nothing's changed. So because if it's true, we will execute the first block of code. This inside of a curly bracket is called a block of code. So the for loop has a block of code denoted by this curly bracket and ended by this curly bracket here. And the if statement has a block as well, which is just printing do this. If the stuff that is standing after the if would evaluate false, we better do this. So the second block is executed. Okay, I hope that makes sense so far. So now this is actually a stupid use case here. So let's do something a little bit more interesting. So for that I will back up a little bit here and tell you something about the modulo operator. The modulo operator is actually asking a question, and that is, what is the remainder of a division? So if I have 3 divided by 2, let's make it, so we get a 1, because this is an int and this is an int, and the return value of it must be an int, and int does not have decimal places. So just to give you that, if you make both of these double, we get 1.5 as an evaluation. So if we would instead, so if we would do this here, 3 divided by 2 means 1, 2 fits into 3. If we would use the modulo operator, which is this percent sign, we get 1 as well. So that's the remainder of our division. So 3 divided by 2 means 2 fits 1 times into 3, and 1 is left. So 1 remainder, and this is actually calculating the remainder. So 4 divided by 2, modulo 2. So 4 divided by 2 is actually 2, remainder 2. A remainder 0, because 2 fits into 4 2 times or twice without any remainder. If we do it with 5, we get 2 times again, but 1 remainder. I hope that makes sense. So basically what the modulo 2 tells us is if that number here is even or odd. So 1 modulo 2 is 1. 2 modulo 2 is 0. 3 modulo 2 is 1. 4 modulo 2 is 0. So what we can do now is ask the question instead of writing false and true in there, and just ask if number, so our current element from the list, modulo 2 is equal to 0. And then we write even. If we write, if it's not, if it's 1, we write odd. When we now run our program, depending on the number we are in, this expression here, this Boolean expression, with this operator modulo evaluates to true or false depending if the number is even or odd. So 1.0 odd, 4. So that's not true because we're printing the doubles here. Let's do a little bit better here. Let's use string extrapolation, which I told you about a little bit. So we're putting this here into a string and doing. Let's do a little bit of a better lock number. So we are writing, so that you see it. We're writing the value of number, a little arrow, and then after that the square root. So you see it like this: 1 will be 1, 2 will be 4, 3 will be 9, 4 will be 16, 5 will be 25, and 6 will be 36. And then we will see 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even. So, that's a lot to digest, right? So this is an example of how to use a for loop and an if-else statement. And this is my first beginning here of control flows. So let's go on to the last topic, and this one is really, really big. Own data types. So we used a lot of data types here: float, double, integer, boolean, strings, and now we want to create our own data type. And one way of creating our own data type is structuring data together into one unit of data. Which data type will we be using? We will now create a data type. What do you mean? So let's back up a little bit. What do you mean with which data type will we be using? You mean later in the calculator, or what we will do? What will we create now? So we will, in the end, to have our representation, we will create our own data types. So that's why we will go over creating own data types now. It's no problem. So we will now create our own data types, and we will, in the second part of this session, we will create our own data types to represent mathematical terms. But now we will try with something different here, and we will start with, and I have to really speed up a little bit. So we will start with structuring data together, and this way create our own data type. And to do this is we use the keyword struct. And we will now create a struct for a person. So we will a person, and we use a block here again, and our person has a first name, which is of type string. Our person has a last name, which is of type string, and our person has a nh. And we make this a variable and not a constant because it can change. A person gets older, right? Okay, this is an int. So this is basically the most simplest way of creating your own data type. We have now a data type called person. And in order to create a variable or constant of this data type, we will just like we did with everything else, we will use, for instance, the var keyword. We gave it a name, me, and now we can use our constructor, initializer basically, to fill the values. So we can just name first name Daniel, last name Key, age 30. So now we have a new data type. And this data type actually makes a structure for us where we can store first name, last name, and age together in one box. And we can access this. We can just go me dot. What is wrong? Oh, of course, age is an int, so we don't need quotation marks. Me dot first name. So this is a property now. Like I said, variables inside of a data type are properties. Daniel. Me dot last name. No, it's not person. Must be key. Actually, right. And me dot age. Actually, I lied a little bit here. I'm actually 31. So let's just correct this and say me age is me age plus 1. So that is possible. Now me dot age evaluates to 31. Okay. There's another thing. If I put here if I go here and put in a let in here, now I get an error in line 108, or actually in 111 I get an 11. So it tells me here that me age equals me age plus 1 is not possible because the me is not mutable. And this means that var is actually a let. So if I want to use this variable state or mutable state of this property, I have to say set this as a var. Okay. So let's add a method to our own data type. Let's add a method which is called description, so that we can easily see what this person is. And every method or function, we start with a keyword called func, like you have seen in the declaration which I showed you by alt clicking some of the function on method names. So I start with func, give it a name, description. In the brackets here I would add the parameters, but we don't need parameters here, so I just do open close brackets, and I define with a little arrow a return value which is of type string. And inside of this block now I will define what the program should do if I call description on any of my data type instances. So description should return a string with contains the first name, the last name is, and the age. Age, years old. So, and if I go down here now and call me.description, this will evaluate and give the following back. Daniel Key is 31 years old. So now we have our own function. Okay. Let's do another function, because one thing that I would suggest is that you don't have variables or properties changeable from the outside of your data type right away. It's always good to wrap these changes inside of a method. So what we want to do is we want to declare this to be not accessible from the outside. So we just don't want to write me.age or me. Actually, we don't want to write me.age anymore. So we will make this private. This will give us some errors now. So because we can't use this initializer anymore. This is something that is a Swift thing. So if you just put this properties in here, Swift will generate you a default initializer as soon as you don't mess around too much. And adding this protection level here, this private statement, actually prevents Swift from creating a default initializer. What we have to do now is create our own one. And initializers are always created without a func keyword. They are actually a little bit like methods, but they don't have a func keyword. They just start with init. Swift initializer declaration. Hit enter. Then you get the parameters. And the parameters are actually you need to initialize each of these properties. So what I will do is I get parameters for each of the property in and assign it to my internal properties. So that is like it's channeling through what's coming in to that, so that it looks like this: first name Daniel, last name Key, age 30, and this is saved in this properties here. So let's go. First name is a string, last name is a string, age is an integer, and then we go self. First name, self is like this data type here, dot first name. So instead of writing me first name, inside of the struct I do a self reference here. So I'm referencing to me as a data type. Self dot first name equals the first name that is given to the initializer. Self dot last name is initialized with last name, which is given to the initializer, and self.age is age. So I can do this here. Instead of this data type struct, I can access and change my variable private here. I can change that. So I can initialize that. And now we have our own initializer. So we can't anymore write me.h, because me.h equals me.h plus 1, because we can't access age from the outside of our data type, our structure. So, but we want to give our structure a method to increase the age, and a good method is to have a birthday, right? Everybody likes to have a birthday, at least up to a certain age. So birthday is a method which does not have a return type. It just changes the inside variable. So we do self.me, self.age equals self.age plus 1. So we're increasing the year. So this will not work. I do this on purpose so that I can explain something here. Birthday is a method which is changing the state or the properties of the data type. And I told you earlier that there are mutating and non-mutating methods. Default is non-mutating. In order to be able to mutate itself so that a method can mutate the data type it is in, we have to declare this to be mutating. And we do this simply by writing mutating in front of it. And now the error goes away, and birthday can actually change the value of the variable age inside of the structure person. Okay, I hope that makes sense. Let's try this out. So you see now, Daniel Key is 30 years old because I don't had a birthday yet. If I call me.birthday and print out my description again, I am now 30 years old. So let me just see if I have everything that I wanted to tell you. Okay, we're actually at the last stretch here before we go over to create our own data type for math representation. I hope you're still with me. It's really quiet in the chat, so I hope you're not asleep already and I bored you to death or something like that. But now we are going to be a little bit more abstract here and we talk about protocols. This is the last ingredient we need, I promise. So what is a protocol? A protocol is a blueprint of methods and properties and other requirements that are particularly important to solve a specific task. So protocols can be adopted by our structures, and these protocols tells other parts of the program that certain stuff is inside these. All of this is common between all of the different structures that adopt or conform to this protocol. So I say that again. A protocol defines a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. Okay. So, what does that mean? So let's say we want to have a list of residents inside. So we want to have a list of residents, and in our house there are living persons and pets. So let's start with creating another structure here real quick. Struct pet, and pet has an animal type, I guess, something like dog, bird, or whatever. We have a name. Some of them have, so we do string optional. So I don't won't name every of my fishes in the aquarium. I don't want to name them, but my dog, of course, has a name, and we give him an age, and we do it the same way that we do it with our age in the person. We give it an initializer which has the animal, so I name it different here. Animal name is a string optional, which defaults to nil if we don't set this parameter. So this is a default parameter here. So you can basically say, if it's not set from the outside, just use this. So we just stick with nil here. And an age, int equals 0. So if you don't set an age, we think that this pet is just born. Has just been born. So self, let's say self animal type equals animal. Self.name equals name, and self.age equals age. Perfect. And then we give it just copy this from here. We give it a description. Now we give it a birthday. So just a birthday right now. Self.age is age plus all. Okay, so I hope this makes sense, because we just did the same like we did before, and adopted it to a different structure. So let's say we want to have a list of residents. Okay, so we do let residents be a list, and we put in me as being the first resident. Okay, so me, everything is good. So we have a list, and inside is a first name Daniel, last name Key, age 31. So that is perfectly fine. I'm a resident here. Then we put in my girlfriend, for instance. So we do another we write it's different here, so we put me in, and we put in my girlfriend, person. First name, Nina. Last name, Ku. And age, 28. Yeah, 28 is correct. So, there's an error. Photo error. So what is it? There should be no error. There's no error. I don't know what it was. How can I do this? Ah, like this. So okay. So now we have a list with two elements, like two persons. So we have residence is of type person. Okay. So let's add my dog. So my former dog. He's not with me anymore, but just for the sake of having him here with me, I add him here. It's a dog. Name, Charlie, and he is 10. Now let's put him in there. Okay. Let's see what happens. Oh. Okay. This is actually not working. So we get a error here. Heterogeneous collection literal could only be inferred to any. Any is this super type of everything in Swift. Everything is any at some point. So the only common ground that Swift can find between a person and a pet is that they are both something. Okay, so let's go there and say that our list is of type any. Okay, that works. So fuck it, why do we need protocols here? I don't see any protocols here. So any is working. So now we have all birthday. So we just, all the residents have birthday at the same day, and so we need a function to call the birthday for every resident. So what we do is we do it with a for loop, right? We go over our residents, and for resident in residence, we go on there and we want to call the birthday method, because we see that this has a birthday method and this has a birthday method. So we just call it, right? Resident.birthday. So easy peasy lemon squeezy, we're done. Not quite. So there's a problem here. Note, cast any to any object are used as to force downcast to a more specific type to access members. Resident.birthday. Value of type any has no member birthday. Why? Our pet has birthday, our person has birthday, but any doesn't. Of course, not any object in Swift has a birthday. So this is where protocols comes in. And to now find a common ground, to define a common ground, we say, okay, we define a protocol which, if both structs conform to this protocol, we know that both must have birthday. And we call this new protocol, and I put this up here so that we can put it in here. So we own data types protocols. We define this protocol and call it has birthday. So, and it's looks like a struct a little bit, but it's a really thank you for following. Thank you very much. Shinkaisoku Yuindo. Thank you very much. So has birthday at the protocol, and it looks a little bit like a struct, but the struct is stripped down just to the declarations. So what we say is that every struct that conforms to has birthday, the protocol, has to have a function called birthday which is mutating. So basically what you do is copy this and put it into your protocol and make sure everything that conforms to it has the same stuff in here. So how do we tell Swift that something is conforming to a protocol? We just add a colon behind our struct name and put in have birthday. And here down with the pet has birthday as well. And now we have a common ground. And we can use this common ground instead of any to put in our residence into the list. So every item in this list, we don't know what kind of structs they are, but what we know is that they all conform to this contract, to this protocol, which tells us that every struct in there has to have a method birthday. And now this should be working, but it's not. But this is a little bit more tricky here. But this is like a little side note. So this is working. We have now our residents, and they all have a birthday, but we now can't call birthday in here. Why is that? When I do Alt click on resident, I see that there is a declaration let resident. And I told you, if you define something as a constant, it is immutable. Even if you have a mutating function, you can't mutate an immutable object. So we have, this is like the default behavior of Swift. It makes everything constant that doesn't explicitly need to be mutable or a variable. So you can use your running variable in the for loop, which is like the first part before the in, is the running variable which runs through all of the elements. To make it mutable, you just write var in front of it. Now this is called, so this is called, and we have like this birthday methods here, and everything is called. And now we can check if it's really called by just checking my age again. Me description must be 32 here after everybody had a birthday. 31. That did not work out because interesting. Let me just check what is wrong here. 30 birthday. 31. That's actually not correct. So why is it? Let me just check. Let me just do another check here. If I go on residence index 1, which is Nina, I go from residence index 1. I know why. I know why. Okay, that's something different here. So why does it not work? Why am I still 31 years old? That is a little bit of a, that's actually stuff I didn't want to deep dive into here, but I will do real quick, so give you a little bit of a deep dive on this thing. So there's a difference between using structures and using classes. Classes is a different kind of your own data type. So, and there are two different ways of moving data around in a program. The one is called okay, let's skip this what it's called. So the one way is to copy data around, to make a copy of your data and put it into the other part of the program. And the other thing is like having a reference, so pointing to a data and say, okay, you know, I have data for you, here it is, and work on that. So what is actually happening? If we structures are always copied around or referenced by value. Copied by reference. So this is actually, if we are moving through our residence array, this resident is actually a copy of our residence in the array. Which means when I call birthday of this resident, it doesn't actually change the value of the resident in the list because it's just copied in there. So yeah, so this is just a side note. But what I really wanted to tell you, if we want to have different kind of structures in one list, we have to have one common denominator in form of a protocol. And we will use this to rebuild our, so let's go in here, our representation, which I showed you. This kind of hierarchy we will build with different kind of structures after a little break. So let's see. Oh, thank you Gigahertz and Starlord91 for following as well. So I guess this was a little bit helpful and a little bit interesting. So I see you after a little break, like let's say 10 minutes or so. I really have to stop the stream really quick because I have to make a cut here of 2 hours so that the video is not too long. And I will be back online in just a couple of minutes, having a little of music playing, and after that we will go on with our representation. If you want, stay for another, I think, hour maybe, and yeah, be with me when implementing this. So, see you in a bit. So, hello, 10 minutes break is over. Yeah, I've got myself a little bit of water. Now we are going to implement our representation of mathematical terms in Swift. This should be a little bit quicker, I think a lot quicker than the last 2 hours. So I think I'll need like 30 minutes or a little bit more for this. Let's get started. So we are here back in Keynote, and this is the hierarchy that we are going to implement. And we will start step by step and try to build this hierarchy from the most simple part to the more complex parts. And I think we're starting with operands, because for operands we don't need actually to have a what is it called? A protocol. We just start with a struct and our own little data type called operand. I already started a new Xcode playground, and we start with operators. So this is a little bit of a Xcode stuff, which will be useful when after we copy this part of the code back to our UI Xcode project. But I want to do this in Playground as well, so that we can play with it a little bit. After, in the next session, we will use the Playground again, I guess, and the session after that we will copy our whole logic back into the Xcode project and connect it with the UI. So what is an operand? Sorry, operators is wrong. Operand. An operand is basically just a struct with the name operand, and it has one value, one unchangeable value, one property, which is called value, and we will calculate everything using doubles. So we have the ability to have decimals in our calculations, and that is basically it. But when I'm using my operand now, if I want to define an operand like op is operand, you will see there's a default initializer created by Swift, which looks like this. And we can op value, we can get the value from the operand, so that we can get the value back. So which version of Xcode are you using? I'm using Xcode 9, so the newest version of Xcode, which was released with the release of iOS 11. So, but I don't want to have these named parameter here, so I will implement a new initializer, which is basically doing the same as the default initializer, but without the named parameter. So we have a little bit more concise writing of initializing our own data types. So init underscore for omitting the name of the parameter, value double is self value equals value. So this should be really familiar to you if you followed the last session. And now I can write operand 5. Operand 5 is just a 5, and it encapsulates the value 5. Okay, this is our operand for now. So now let's define our first operators. So when you look at our keynote, you see that we have multiplicative, additive, unary operators, binary operators, which are operators. So if you look at this, and you can like say that a multiplicative operator is a binary operator, which is an operator again, you will see that we have there some kind of hierarchy. And protocols actually are creating this type of hierarchy. So what I want to do is I want to have a protocol named operator. Okay, I want to have a protocol which is an operator. Why do I want that? Because I want to store or handle different stuff on operators the same way later when I'm calculating stuff, and different than I do it on operands. So this is actually like grouping our subtypes, sub-data types. So there's a kind of an inheritance going on in this hierarchy differently than I do with the operands. So it's like a grouping of this, or representation of this hierarchy tree here. So we have a protocol operator. Then we have binary and unary operators. So let's go on and try to implement our unary operators, the first unary operators, because they are the simplest. They just have one operand and they would do something with it and return the new operand, so the new value if you want to. So let's do it, and let's say that we yeah, each unary operator is an operator. So this says that our unary operator protocol is conforming to our operator protocol. And a unary operator has one function. We say that the unary operator, every struct or every struct that conforms to our unary operator protocol needs to implement one function. And this is the func eval, short for evaluate, which takes one operand of type operand. So a unary operator, as I told you in the beginning of the last session, is basically an operator which takes one operand and does something with it. For instance, if you have the plus minus operator, it either negates a positive value or negates a negative value, making it positive again. So let's start with that. Now this is all abstract, so there's no actual code. This is just telling what there should be. But now we are actually implementing some logic here. So let's go on and implement our negate operator. So struct negate should conform to the protocol negate operator. So when I do that, Xcode will tell me type negate does not conform to protocol unary operator. That is because we don't have implemented a function called eval by now. But this is actually the contract we go in if we say that we want to be a unary operator. So we can click here and do you want to add protocol stubs? Of course, fix it. And now you see that Xcode added this empty function to our negate operator, which is basically conforming now to our defined function up here in line 18 to have an eval function with one operand. So what is actually happening here? Oh, sorry. I missed something here. I forgot. Our eval function should return an operand as well. So when you have 5 negated, it's minus 5, which will return a value, an operand, with the value minus 5. So what we do is we return, if you want to return something from a function or a method in this case, you use the return keyword. This way you can return a value back from the function to the calling code. Hope that makes sense. I I let this out in the basics, but this is a good way to show it actually. So if we want to return an operand, and this operand should have the operand value, but minus. So this operand, we get the value of it, put a minus in front of it, and return this. And this should be returning an operand. Okay, let's try that out. So that's why we are on the playground here. So we are creating an operand here. Let OP equal operand 5 again. So we get our own data type called operand, which encapsulated the 5. And now we want to use negate as an negate on that operand. In our representation, we need an operator here. Let's call this operand, and this operator. Okay, operator is a saved word, so let's call this operator with a 0, like lead, and give it our custom type negate, which has no properties, so no initialization parameters. And now let's evaluate our operand using our operator. So operator dot eval with our operand, and this is calling our evaluation function, passing in our 5 wrapped in an operand, and it returns an operand. And if we can now dot value here, because this part of the code is evaluating to be of type operand, we can then dot access the property value, and we see that we get a -5. So that is actually working. Our first operator, negate, is working. Let's go on, because it's working so good so far. Let's implement our second operator for our calculator, which is the %. Let's call this % unary operator. Let us help. Let Xcode help us. And what we do now is we return an operand, taking the operand value times 0.01. So the % operator is nothing more like divide by 100, basically. So let's try this down here with our operand 5 and replace the operator by % instead of negate. Now our operator evaluates the operand to the value of 0.05. Okay, I hope that makes sense. So this is the implementation of our first negate and % unary operators. So you might say, why do we need all this protocols here? We could just implement negate, evaluate, % evaluate. True. But in the end, we want to have a list of operands and operators so that we can write out a term like 12 times 256 minus 8 divided by 3. We want to store this different tokens here, operand, operator, operand, operator, operand, operator, operand, in one list of tokens. That is actually why we need this common protocol for all of our hierarchy here. So one thing we have to do is to have a protocol token in here, basically like this empty protocol operator, and make an operand to be a token, and operator to be a token. So there's a question, Starlord91. I will come to that in a moment. Let me just finish that here. So what we want to do is we want to be able, if we have like this equation here, -5, we want to write this in form of a term. We want to have let term be a list of five. We enter a 5 on the calculator, and temp on the negate button. We want to put a negate operator in our list. So this is actually later. Sorry. We have to wrap this around an operand here. So in order, just check. Operator is token, operand is token, so term is of token. So we can now write our term to be a list of operands and operators, or basically just tokens, which we enter on the calculator. That's why we started with the calculator 101, to get you now to the idea why we do this. So when we're starting writing a number, we write the number, we save the digits, and as soon as we hit a operator, we will save this number to be an operand in the list, and after that we save the operator into the list so that we can save the term. I hope that makes sense. So, Starlord91 is asking, is 0.01 the smallest value in Xcode, which we use for percentage? I'm not sure if I get the question correctly, but 0.01 is not the smallest value in Xcode. It's not the smallest value. Xcode is more, so there are different stuff here to distinguish. So Xcode is an IDE, stands for Integrated Development Environment. So this is not that's basically just the tool that helps you to program stuff. Swift is the programming language you use in Xcode. So you use Xcode to program in Swift, which is then compiled to be a program on your machine. So the lowest value a program can use is down to the hardware your program is running on. So you have this different parts in your system on the computer, like you have a CPU, you have a central processing unit, CPU, you have a GPU, graphics processing unit, or graphical processing unit, and all these different processes are having different limitations in storing numbers. And actually, the smallest number for a float, for instance, or the data type float and double are determining the lowest number depending on how many bits your system supports. So for 64 bits, it's a smaller number. The smallest number is way smaller than it can show on a 32-bit system. So this is a lot of technical stuff that doesn't really matter right now, and it would like burst the frame of this course, but just so that you understand that the question you're asking has different layers to it, which we use for percentage. For percentage we use 0.01, of course, because if you type in 1, and 1% is 0.01. So let's say if you have a number like 50. No, okay, 50 is stupid. Let's make it simple. If you have 100 and you want to have 1% of 100, you can type 1% times 100, which gives you, in our evaluation, 1% to be 1.01 times 100 is 1. So 1% of 100 is 1, which makes sense because that's basically the definition of percent. 1% is 100 still. So I hope that makes sense then. So we have the unary operators and the negate and percent operators we have. We can write it like this, and we have a way to store it in a list of operands and operators. So let's go on. We have now our multiplicative and additive operators, which are both binary operators. So what I want to do now is to create a protocol for binary operators. And this is not conforming to unary operator because they are on the same level, binary unary. They are both conforming to operator. So the difference between a binary and unary operator is that the unary operator just takes one operand, whereas the binary operator takes two. So our eval function for the unary operator is not working for our binary operators. We need a new eval function. I just copied this down here and say that we have a operand A and an operand B. Okay, cool. But now we can start and implement our binary we can't just start and implement our binary operators, which like we did with our unary operators. We have to add another abstraction layer here, because we have to distinguish between multiplicative and additive operators. Because multiplicative operators have to be evaluated first before we can use the additive operators. That's because we have a different, we have a certain order of operations that we have to do. So multiplication and division have to be always evaluated before subtraction and addition. So we add another layer of protocols here. We have a protocol let's start with the stronger one. It doesn't really matter, but it's my taste. Multiplicative operator, which is conforming to the binary operator. It's already it's just an empty protocol. It's don't adding new kind of information. It's just grouping. And you will see next session, so next week, why this is important. I will reference back to this a lot, and we will talk about this. And maybe something might be a little bit seem a little bit over-engineered to you now, but bear with me, you will be understanding it next week. And we have our additive operator. So let's implement them. So we have the multiplicative operator, of course, the multiplication. So we call this, now we are implementing again, so we don't use struct. A struct is just defining the different stuff that is equal and grouping the stuff, but really implementing, we use our structs. So multiplication is a multiplicative, of course it's a multiplicative operator. So Xcode will tell us that we have to conform to the protocol in just a couple of seconds. And it does, but it's not showing here, so I just help him. I copy this, put it in here, put it in there. So how do we multiplicate two operands? We just do A value times B value and wrap this result again in an operand and return it. Easy. And the same we do with the division. It's multiplicative operator as well. We do all the same, but just doing the division in there. That's easy. So let's test them out real quick. So let's do a operand A and an operand B in here, like 3. And let's try out our operator to be a multiplication. We add the plus, operand 5, times, and after that 265. And this should actually evaluate to be 1337. Okay, this needs to be explicitly to be a list of tokens. And yeah, that's basically how we would represent this equation inside of our representation. How would we actually calculate that? That's the topic of the next session. But I will show you really quickly how we can do this for this specific example, how we can build the right calculations, but to make this work for every type of combination we can type into this list, we have to implement something that is called an LR parser, and we will implement that next week. But let's really quickly calculate and see that our representation can actually calculate what we want it to be. So we can do the following. We take the percent. So this is 0, 1, and these are the indexes. So term. So there's a question. How long have you worked with Swift? With Swift since it came out. So 2015, beginning of 15, right? So 2.5 years, I guess. So we're taking the percent operator, 1. We have to use, we now must make sure that it is an operator, a unary operator, as unary operator. So this is a little bit complicated right now, but maybe you can see what I mean. So then we evaluate the operand 1. So we put in 0 as operand. dot value. So let's try this out. So this must be the first step. So 10 times percent 0.1. Then this result here is the first operand of our multiplication. So we have to wrap this. So we get an operand back, and we put this into our multiplication, which is term item 2 dot as binary operator our first, and the second half of the multiplication is this operand here. So, you know, I write it a little bit different. I see that this is not really speaking anymore. So let's just make it a little different. Let's define, we need a percent to be percent. We need a multiplication to be a multiplication. We need a addition, and that's it, right? Yeah, addition. So to build this kind of, or to evaluate this kind of list, what we have to do, just really simple here. We will go into this more in detail next time. Percent eval, and getting the operand here, operand of 10. And this is the first operand of a multiplication, A, and the second is an operand 120. So this here. This is all part of an addition, where the first part is this multiplication and the second part is another multiplication. So we put in a multiplication, eval 5 operand 5 and operand 2, 6, 5. And this must be eval. Okay. Making all the brackets right, checking if this is working. Let's write it a little bit different. The addition, percent, this is wrong. A, B, and let's write this a little bit clearer. This is the end of the multiplication. So let's see if I can make it this way. Write it up a way that it is actually easy to see that this is a good way to represent the stuff. Good, I think this is a good way to see what is happening and to see if that is really the right result. We will put in value, and we see that this term here is evaluating to 1337. So let's go through this a little bit more. So what we do first is we have this addition here. But this addition can't be calculated unless we calculate the multiplication on both ends first, because they have to be evaluated first. So we have a multiplication here and I have a multiplication here. So the second one has just the operands 5 and 2, 6, 5. So we can put them in here. The first one has a unary operator here, which is applied to operand 10. So we have to put this in for the first operand calculation of our first multiplication and multiply this with 120. And then we can use this result from this multiplication and this multiplication to add it up and get the end result. Okay, bam. That's it for today. I'm done. We have a nice representation of mathematical terms in Swift. We have seen how we can use it to actually calculating stuff in a really lengthy and typing intensive way. So this is actually not, I wouldn't do that to write your common whatever math terms in your Swift programming, but this is actually something we need to interpret the entries to the calculator correctly and to give the right result. Okay, I'm done. I guess you are done. You have a lot to think about. I will save this up, put it into the zip file and upload the new zip file right away after I am done with the stream. So, if there are any questions left, now's the time to ask. If there are any remarks you have on how to make this better, now's the time to say them. If you like what you saw, please feel free to subscribe and and join me next week again here, and then we will use our representation to actually interpret real lists of terms. You will see how this works, and I hope I will get through this in 1 hour next time, not use up too much of your time. Thank you very much for the compliment. I'm glad you liked it. So I guess there aren't any more questions, so I say have a good night, have a good day, have a good morning, depending on when you watch this and where you are right now, and see you next week. Bye. Hello! I hope you can hear me. I hope. Let's put this here. Oh wow. Just fix that. So, how are we? It's time again for a little bit of Swift coding and developing a simple calculator in Swift. As always, we will do a little bit of theoretical stuff first, and then we will get our hands dirty with some programming. Today we're going to write the actual calculating part of our calculator. Last time we did a mathematical representation. How can we store mathematical terms in Swift? And the first session was about creating the UI. And today's session may or may not be a little bit hard to comprehend at first, but I think I made sure that I chew through a lot of this stuff a couple of times, so that even if you are a beginner or not that far on your programming journey, I hope you will get the concepts I'm about to show you. And I'm pretty excited because this is actually something really interesting, and as soon as it clicks with you, your programming will get a lot better, I think, and you will be able to solve rather complicated stuff using this new technique I'm going to show you a lot easier and more elegantly. Okay, I think let's get to it. So, everything in place. Here we go. Hope that works. Good. So I'm just checking if my stream is correctly and my screen is now shown, but there's a little delay, so I have to wait a couple of seconds. I think, yeah, that seems to work. Good. So let's see. Let's do a little session to recap. Really quick, what did we talk about last time? First of all, we were talking about a lot of basic Swift concepts. So if you didn't have any experience in programming, I definitely recommend watching this stream of last week again. So we talked about storing data in variables and constants. We talked about different kinds of data. We talked about operations we can do on this data. We talked about functions and how we use them, how we can use parameters and return values to build little Okay, I hope everything will be working fine by now, but you never know. Okay, let's get back to it. So where were I? So methods, optionals. I think I just start with functions again. I don't know when the stream broke exactly, so functions, basically we learned about it, are a concept to encapsulate reusable code using a function name where you can put data in and get some data out. Methods are the same as functions, but they are strictly and close coupled to a data type. And optionals, a concept in Swift where we give a variable the possibility to be empty, which is called a nil value. Collections are basically a different kind of data type where you can store multiple instances or multiple copies of a data type in. So you can think of it like a list. An array is more like a fancy name for a list. Okay, this is pretty colloquial speaking here. There are major differences, but I think you get what I mean. We talked about control flow, so if else and for in. We talked about a for loop. We talked about if and else. We defined our own data structures. We talked about protocols, which are basically a contract between different data structures in terms of the contract says what a certain data structure should have in terms of methods or properties. where property is just a fancy name for saying variables in a data structure. As functions are methods in data structures, properties are the variables just in a data structure. And we build our representation for a mathematical term using our own protocols and data structures. Okay, so this was our model. This was what we came up with, and just to give you a little repetition on that. So everything that we have in a mathematical term is a token. So if we have a term like 5 plus 4, 5 plus and 4 are each tokens. So we have 3 tokens in a list that defines our mathematical term. We then can distinguish between operands and operators. Operands being the values that we use in the mathematical term, and operators being the operations like addition, multiplication, percent, or what was the else, negate. That are the 4 operators we have on our calculator. And the operands would be in 5 plus 4 would be the 5 and the 4. In the operators, we can distinguish between binary and unary operators. Binary means by, like 2, so we have 2 operands going into the operator, and there we can calculate the value. And unary means un, like for 1, we have just 1 operand going in there. Examples for unary operators would be percent, and negate. The binary operators we have to distinguish into multiplicative and additive operators, where multiplicative operators are the multiplication, of course, and the division, and additive operators are the addition and the subtraction. We have to do this distinguishing between multiplicative and additive operators because we want to do all the multiplications and divisions before we do the additions and the subtractions. We will talk about this today in depth. Okay, so what we currently have is a list of operand and operations, or a list of tokens with which we can define a term. Okay. Just see, I don't mind. The green screen is acting up a little bit. Maybe I should fix that in a sec, but let's see how it goes. Good. Now what we want to do now is we want to define a calculator which can actually evaluate this list of operands and operators and give us the right result. So, session 3, calculating mathematical terms. If there are any questions regarding the last 2 sessions, now would be a good time to ask. Otherwise, I will go forward and just bash through to new knowledge. Good. If there are no questions, let's go on. So, the agenda for today. We will do a little X course and talk about loops versus recursion. So, if you don't know what recursion is, at the end of this session you will know. Hopefully, that's my goal. Evaluation of terms and examples. We will do a pseudocode for our calculator so that we have a very good idea of what we're going to write before we even start to program this stuff. We will do a little break in between the theoretical part and the coding part, just because the theoretical part today is maybe a little hard to grasp, maybe a little harder to grasp than the last time. But so there's a little 15 minutes break for questions and to comprehend all the new knowledge you by then have, and after that we go on to code. So, a question regarding session 1. Wetrix is asking, when we make UI for different sizes, phones and tablets, is there universal resolution? No. There's no universal resolution in terms of how many pixels you have or points you have on a device screen. But you have a universal depth or density of pixels. So what you basically do is you position and design your stuff in points, which is actually related back to the old days when we had iPhones without retina displays, and the UI engine scales this up to the right dot per inch scale. But still there is different screen aspect ratios, and therefore you have different resolutions in displays, so therefore you have different amount of points to design for when you have different devices. So I hope that that helps and clears that up a little. Recursion. Recursion occurs when a thing is defined in terms of itself or of its type. So this last or of its type we can totally forget about that, but recursion is basically defined as defining something with itself. Sometimes I have little memes in here. I don't always comment on them, so I'll just let you read through them, and maybe you find them funny. I found them funny. Okay, so let's do a little bit of a small and simple example of how to calculate stuff in a loop versus in a recursion. And we do that with the calculation of the factorial of a number. The factorial of a number is defined as n exclamation mark, is basically 1 times 2 times 3 up to n. Or if you know your mathematical notations, you have this big pi, this product symbol with the loop from k1 to n over k. So if you know your math, that's how you mathematically define the factorial of a number. If you don't, here's the normal way of saying what it is. N exclamation mark is called the factorial of n. Okay, we know that by now. And as an example, if you have 5, factorial of 5, you have 1 times 2 times 3 times 4 times 5, adding up to 120, I guess. So that is a mistake. Let me just fix that real quick. Oh, nobody saw it. 120. Let me just check. 5 exclamation mark 120. Okay, so let's implement the factorial, and we do that in the playground. So oh, hello. That looks stupid here. Let me just fix that quickly. Oh yes, this little. So. Okay. That's not the playground. That is the playground. Okay, we want to define a function which is called factorial, which calculates this here. So we have an input parameter called n of type integer, and we want to return a new integer. What we want to do, we will do this in a loop right now. So the best way to start is to have some kind of result accumulator, stuff where we can put the result in, and I call this variable result and initialize it with 1. And then I have a for loop which is running my variable I in a range from 2 to n. Why 2? Because if you look, you will see in a minute. So bear with me. We're going from 2 to n, and each cycle we will do the result is equal to the result times I. And after that we will return the result. So let's check if that is correct. Starlord91 asks, I have not worked with Playground before. Is that function in Swift? The Playground is basically a little just-in-time compiler which you can start when you're creating a new Xcode project. So what you do is when you go to your Xcode and let me just copy this real quick and I show you. So I start my Xcode, I get this window here, and there's a button down here, get started with the playground. When I hit that, I'm asked if I want to use a template. I used the blank one. After that you will ask for a save location, and then you get the same thing that I showed you before. So let's just go back, open the recent playground, and here we are again. I hope that clears that up. So so let's go over the code in the head for now before we even try it. So what we have is our result. We call this function with it let's say 5, and we go in there, put result in 1, and then we have I equals 2, and then we do 1 times 2. 1 times 2. Okay, next loop. I is now 3. So we do result, which is 1 times 2, and make it times 3. 1, 2, 3. I think you're now getting how it works. Next loop with 4. A result is now 1 times 2 times 3 times 4. And the last run, because then 5i is equal to n, will be 1 times 2 times 3 times 4 times 5. So we are actually calculating the factorial. So just-in-time compiler means Starlord. I can just go in here, write this, factorial 5, and now the playground is running and is actually giving me the result on this side. So that's basically what a playground is for. And don't worry, you can ask every question here. Good. So that is our loop to calculate a factorial. Pretty easy, right? Let's get back. But we can do better. Let's look what we do here. So we have our factorial of 5. And as I told you like multiple times, it's 1 times 2 times 3 times 4 times 5. So if you look at that, we see that 5 factorial is this number of products. And we look at the 1 times 2 times 3 times 4, we can notice that this is actually the same than the factorial of 4. Looking at that again, 1 times 2 times 3 is the same as the factorial of 3. 1 times 2, the factorial of 2. 1, the factorial of 1. Okay. What does that mean? We can write our factorial of 5 as the factorial of 4 times 5. We can write the factorial of 4 as being the factorial of 3 times 4. And so on. Until we reach the point where we actually know that the factorial of 1 is 1. Okay. This, ladies and gentlemen, is called recursive, because we are defining the factorial of 5 with a self-reference of the factorial of 4. So if you remember, the definition of a recursion is defining something using itself. And at the end, we have a so-called end condition or endpoint of the recursion, which has no self-reference. Okay, I hope that makes sense. So we can define our recursion as the recursion of n is equal to the recursion of n minus 1 times n. Okay, hope you got that. If there are questions, please get them out now, because this will get even more interesting. So now we can define our factorial using a recursion, using itself. So we don't need the loop, we don't need the aggregation, we just need 2 lines of code inside of the function. First, we have our end condition. So if an I, so this is C++, but don't worry, it's pretty self-explanatory. This is the function name, this is the return value, this is the parameter. So I is an integer, like we have in Swift. It goes in there and you can use it in the function. So if I is equal to 0, we just return 1. Cool. So no self-reference. We know that this is pretty easy to calculate. If it's bigger than 0, we return I times factorial of I minus 1. So if this is 5, we put 5 in here, check it, and put 4 in here, and make it times 5. But actually, before I show it here, I think I have slides for that. This part here actually is called the recursion. So this is a recursive function using a recursion and an end condition. If you or your recursion is written in a way that the end condition is never met, then you're basically creating an endless loop or an endless recursion, which will end up in a stack overflow. So let's brain it. We have the factorial of 5. The factorial of 5 is defined by 5 times the factorial of 4. We return this value. the factorial of 4 is defined as 4 times the factorial of 3. The factorial of 3 is defined as 3 times the factorial of 2. The factorial of 2 is defined as 2 times the factorial of 1. The factorial of 1 is defined as 1 times the factorial of 0. And now we hit our end condition. So there's no self-reference, we just return 1. And this was the way down the rabbit hole. So recursions often have two separate parts. One is going down by calling itself multiple times, like an inception, going from one dream to the next, to the next, to the next. And the other part of the recursion is going up again. So, Shinkai Soku, I read your question. I will address this later, since I think we now have to stick to the recursive topic so that you don't lose your thread here. So I think this is really important for the next step we're going to do. So I will answer that later, please. So we hit our end condition, and now the return actually is the return of this function call. So this function returns a 1, and so we can rewrite this term here and put the 1 in there. And 1 times 1 multiplied by 1 is 1. This 1 is the return value of this function, which then ends up to be return 2 times 1. This is the return value of this function, putting it in there, 3 times 2. 6, the return value of this function, 4 times 6 equals 24. 24 is the return value of factorial 4. 5 times 24 equals 120. So our recursive factorial 5 exactly calculates the same. Okay. Everybody understands what a recursion is, how it works, and how it is, how the thinking goes? Okay. Let's talk about why would I use recursion when I already have loops? A good question. So first of all, you gotta know that you can basically write every code in which you have a loop as a recursion and vice versa. So they are both equally mighty. And you shouldn't always use recursions just because you think they are cool or more pro or whatever. That's not a really good way to do it. But if you find when you're analyzing the stuff you're doing that you are having a self-referencing algorithm in some kind that is actually calling itself over and over again but with different parameters, then a recursion is most likely to be shorter, a more elegant way to program it, easier to understand, and that way easier to prove correct. Okay, next up, calculating mathematical terms. But before we switch to this topic, I will answer the question. How should one handle errors in Swift? That's actually a pretty broad question to ask, and there are different people having different opinions on that, and it a little bit depends on what you're trying to do. So there are this concept of exceptions in Swift as well. And exceptions are a good way of handling your errors. So if you have your exceptions, you can throw them and they will stop executing the code. You may have to do some cleanup afterwards, and you can escalate the exception up the hierarchy of your objects and then handle it at some point. So exceptions are a pretty good way. Another good way is if you just have one error case, or you don't need the information about what is actually going wrong, but you simply just know that something is going wrong. For instance, if you so basically you're creating an object and something went wrong. A good way to handle this is to return nil, or a easy way to handle this is to return nil, and in the calling code check if the object was correctly created, and if it's not, handle the error there in an if-else statement. That's a way to do it, but exceptions are, I think, the most versatile method. Another way is if you have asynchronous stuff going on. There's this. They sometimes parameterize your functions with blocks or closures. Then it's sometimes good to have a closure for success case and the failure case, and hand the failure case some kind of an NS or error object, so that you can have more information on your on what went wrong. Okay, I hope that helps a little to find a good way to handle your errors, and we can go back to calculating mathematical terms. So I have to go through some examples with you again, just to get an idea of what we're dealing with here. So we have this eval function we want to implement. So we want to put a list of tokens and operands or tokens into this eval function, and want to get a result back. So the first case, sorry, I already went to the second one. The first case is we put in an empty list. Empty list is always a good state. So if the term is empty, the result is 0. If you don't type anything into the calculator, hit the equality result button, you get in 0. If you just have a list with one operator or a couple of operators but no operands, you get 0. So because if you just hit plus and equal, there's no way we could calculate that without some numbers in there, so it is 0. If we are just entering a number and hit equal, this should be 5. So 5 is equal to 5. Unary operators. So we have a list with one operand and one unary operator. We can simply evaluate that to be 5% of 5 is 0.05, and 5 with the negate function plus minus button gives us a -5. So 5 turns out to be -5 after we hit the button. Doing this, like having a operand and 2 unary operators, we evaluate this and then we evaluate everything. So hitting the negate button twice, we will end up with a 5 again. So binary operators. We have a list with an operand, a multiplication sign or multiplication operator, and a operand 265. We take the operands, put them into the operator, and get the result. Equal for the plus. And if we do this, 5 times 265 plus 12, we get lead 1337. And the other way around, 12 plus 265, multiplied by 5 is the same, and that's something we have to work at, because we can't just go from left to right in this list, but if you would do so, we would first do the addition and then the multiplication, which would lead to a different and wrong result. So this case here is really important, and today everything that we did last week in discerning multiplicative and additive operators will make sense finally. Let's do the evaluation step by step, which we did last time as well. So we have our first unary operator, which gets evaluated to 0.01. After that, we will evaluate the multiplication to be equal to 12. Sorry, we can't evaluate the plus here because we have this multiplication down the line. So we have to do the multiplication first, and after that add both parts up and get the final result. So that's how it should work. So let's look at what we did there. So what are the rules we can get from this? So I wanted that to be coming in from top to bottom. So, but now you see all the truth at one slide. But let me go through this from top to bottom. So what we did, we evaluated the tokens from left to right. So we were going here, doing the unary stuff, going here, doing the multiplication, and so on. We always looked at the number and at the operator, then again at the number, at the next operator. So what we did actually as humans was we were scanning, looking on the number and the operator together. So what we do is evaluate a token from left to right, always look at the next token in the list. Good. If the next token, like this percent sign for instance, is a unary operator, we will evaluate that instantly. That's what we did. 10% becomes 0.01. If the next token is a multiplicative operator, we evaluate the current token. So that's what in front is, what's in front of the multiplication, and the next token after the operator, so after the operation, the 120, instantly. So we were calculating 0.01 times 120. Good, that's a simple rule. If the next token is an additive operator, like in this case, we did first evaluate the rest of the list after the operator, and then use the result to do the addition. So let's think about it. Did we do that? So we evaluated this part, saw that this is a plus, and went on to this part and evaluated the rest of the list and everything that's behind it. If there was another whatever unary operator, or there were another multiplication here, we would do all of this before we can actually evaluate the plus. So on this stuff, this rule set here, which is pretty specific for our calculator, has actually a name that is used in computer science, and it's called left to right parsing, or LR parsing, and sometimes LR parsing with a lookout of 1, which means we look at the next token to identify the action that we have to take. So I hope that makes sense so far. And this is actually stuff I learned in my 3rd semester in computer science. So if you're just starting out and learning this, and you're getting this instantly, you're good to go here. So recursion is like 1st semester in computer science here in my university, and the LR parsing stuff, and which is actually a foundation for writing your own it's a basic foundation for writing your own programming language, which just to give you a little bit more excitement about the stuff we're learning here. And if you want to know more, just type in LR parsing and get yourself happy with YouTube there. There's a lot to find. Okay, and now we bring both things together, because LR parsing is actually a recursive algorithm. Good, let's do it. Let's do the LR parsing again, but this time we use our list writing here. So we are doing the LR parsing in the brain using this list of tokens and operands. So, like I said, we look at the current and the next token, and by that we see that we have to evaluate this this combination instantly, because it's a unary operator. That was rule 2. First rule was go for left to right. The second rule is unary operators first. So we do that. Now we have this number and this operator. So we see a multiplication. The rule was we now have to evaluate the two tokens next to the operator with the operator. We get a 12. We look here, have a 12 and a 5. This is an additive operator, so we said that we have to evaluate the rest of the list first. So we do the eval here, eval times 265. So keep in mind this could be longer, so we could have all of this here in this list and would go another recursion tree. But we only have 5 times, so we have a multiplication again. We can redo that instantly, so we get the result, and as soon as we have the result of the two evaluations, we go for 12 plus 1325 and get the result. So a question, what does LR stand for? LR stands for left to right, from the left to the right. So we got going through the list, starting at the left, looking only one token ahead, and this way evaluating our mathematical expression. So, calculation examples again. So I just brought up this list because now we want to see why this is a recursive thing. We have three end conditions here. Stuff we can use instantly and return, and all of this other stuff here can be actually written as if it would recall this. So we evaluate this and get back a number, which is actually this, return the number. If we have this here, we can evaluate this and this part and then multiply it and return the number. So you will see how this turns into recursion in a bit, but yeah, these are our end conditions. So let's go through our code, which we will write in a couple of minutes, but let's do it in a little bit of a simpler pseudocode style. So we have a function eval, which gets a stack. Stack is a name for a list of tokens, basically. A list. Stack is a fancy list, where you basically, if you have a stack of books, you can't pull a book down here or a plate. You can only put a plate up there, or let me start again. So if you have a stack of plates, you can only put a plate on top of it and get the last stack, the last plate of it. So if you want to pull a plate out from the middle, this is usually a little bit harder and may end up in the tower of plates crashing. So that's basically the definition of a stack. So But this is just so that you heard of it. It doesn't really matter for the details here. It's just to use the right vocabulary through this sessions. So we have one list of tokens or one stack of tokens, and eval makes it a new stack of tokens. So that's our function. So this here are our ending conditions. Like if you remember the factorial stuff, we had this if I is equal 0, return 1. This is the equivalent to that. So, first of all, if our stack is empty, we return a 0. Or, if the first element of the stack is not an operand, so not a number, we can't calculate it actually, that's a wrong term, we return 0. If a term starts with a plus or a minus, we can't know what to do with it. We always have to have a number first and an operand second. Sorry, operator second. So that's our return 0 case. Then there's another case. If the stack length, so the amount of plates on the stack, or tokens in our case, is equal to 1, we can just return the stack value, because it has to be an operand. Because of our first case, we make sure that always the first element in a stack is a number, is a value that we can return to the outside world. So if it's only one of these, it must be an operand or a number. So that's basically the result of our calculation, the last step, the end condition we are looking for. Okay, so our first rule was if our next token, so our first token is always stack 0, because that's the index of the first element in the list, and our next token is stack 1. So we're basically looking one ahead. If that is a unary operator, we will get our value in front of it and put it into our operator structure which has an eval function. If you remember what we did last session, we then, for instance, if that is the percent operator and this is a 5, the value that it returns is 0.05. And then what we do now, we create a variable new stack and replacing the operand and operator with the calculated value. So if you remember what we did on the slides, the 10 and the percent was replaced and reduced to the 0.01. So that's this step. And then we return, we call on the new stack, we call eval. So we start up here again and have the same kind of options we are working out here, and do this with a new stack, which is actually then 0.01 times whatever. So, but we will do that, we will go through that a couple of times later, so if you don't get it now, just bear with me a little. So the next rule was, if it is a multiplicative operator, we will use the operand in front of the multiplicative operator. We use the operator, like in some, maybe a multiplication or a division, remove that from the stack as well. And we have the operand, so the number after the multiplication stuff. and we will then call the operator.eval function with the two operands and get the multiplication or division value in value. And after that, we removed the operand or operator stuff, and now we put the result of this multiplication in there, and then we will call eval again. So this is a recursive step, and here's another recursive step. And the last rule we had was if the next operator is an additive operator, we get the operand, we get the operator, and we first evaluate the rest after the plus. So we call okay. Sorry for that, I don't know what it is, but somehow the stream broke again. So we just go on and hope that everything will be fine from now on. I keep an eye on it, and as soon as it breaks, I will just restart my OBS and I'm back in a sec. So let's run through this real quickly again. So 5 times 265 plus 12. We check the second item, which is a multiplicative operator. We evaluate 5 times 265, getting a result of 1325. We put this result back into the stack instead of our 5 times 265. So our new list is 1325 plus 12. Now we run eval on that. Now we are in the recursion. We're calling ourselves with a new list. The new list is only 1325 plus 12. We look at the second item, the operator, and see that it's additive. So we remove the 1325 and save it for later. We remove the operator and save it for later. And the rest, so the other part of the list, we evaluate, which is only the 12, which is one of our end conditions. If there's only a value, we return the 12. Now we go up the recursion again. So the result of this here is 12. So we're now evaluating 1325 plus 12, which is 1337. We return that up to here, and this is simply a return eval. So return the result, and we're done. This is our result. So our recursion went down the rabbit hole and up again and brought up the right result. Let's do this the other way around. So 12 plus 5 times 265. So now we check this again from left to right. We're checking the operator. See, it's an addition. We save the operand. We save the operator. And we move to the last part, so the rest of the list, and evaluate that first. So now we call our function eval with 5 times 265. We check the second item, which is a multiplicative operator. We then evaluate 5 times 265, which is 1325. We put that back into the stack. We have a new stack which only contains our value, our operand, and evaluate that. This is an end condition because only one operand. We return the value 1325 up to the level. We have now This one is just returning a level up again. And now we have our value for rest, which is 1325, which you can now use with our operand and our plus to evaluate 12 plus 1325 equals to 1337, which is then returned and is the return value of our first call. And this, ladies and gentlemen, evaluates to 13372. So we have now a calculator which is actually calculating mathematical terms and respecting the rule that multiplication and division has to be evaluated before we can evaluate subtraction and addition. So let's build this step by step. But before we do that, just a little break. I need some new water. I know we had a break already because of the stream outage, so I will do this short, like just 5 minutes, maybe 10. Give you some time. If you have questions now regarding the recursion, regarding the evaluation of mathematical terms, or stuff regarding our other sessions or Swift in general, this is a good time. Just write it in the chat, I will read it, and I will be back in just 5 minutes and have a fresh new playground for you. Okay, I'm back. Just restarted the router, and hopefully this will last until we're done here. So implementing that after we did so much theoretical work up front is actually not a big thing anymore. There weren't any questions, so I think that is a good sign that this is understandable and you could actually figure out how a recursion and how the left to right parser with one look ahead is working. And let's get on to do some coding. So this is the project we had last week. So just to go through this real quickly, we had our protocols which defined a token. Then from that we had the distinguishing between an operand, which has a value, and an operator, which is in protocol itself. We distinguish between a unary operator protocol, which can be a negate operation or a percent operation. And we have our binary operators, which we can distinguish into multiplicative operators, the multiplication, which has an eval function getting two operands returning a times b, and a division operator, which returns respectively a divided by b. The additive operators are here our addition and subtraction, and then we did some playing here with our stuff, which I will quickly erase to clean this up. Now we can start implementing our actually calculator. So our calculator is a struct as well. So let's do this here, giving a little mark, calculator, and we put in a struct named calculator. And so our calculator has this eval function. The eval function we want to call by calling calculator.eval. So there's a new concept here, which is called a static method. So static means that we don't have to have an instance of a calculator to call this. We can just call it on the data type itself. So if we have the operators and we have this method eval, we always had to do a operation, whatever, like addition, and get ourselves a instant of that. So we had this calling the constructor of this and getting the addition struct as an instance back, and then we could call addition whatever eval with an operand, sorry, of 5 and an operand of 4, and this would give us the result dot value shunting yard algorithm. I don't know, maybe, don't know, can't recall the name of the algorithm. I look it up, the shunting yard. So I put a note there so I can read it up. So the algorithm we use for the calculator is actually the algorithm we developed together during the last hour. It's an LR parser. If the shunting yard algorithm is basically a stack, and a stack is a list of tokens, and as we get an operand. Okay, so we remembered our first two steps for the algorithm, which were to check if the stack is empty, or if the stack is not valid, means starting with an operator, and therefore return 0. So what we do for that is a guard statement. A guard statement basically is guarding the entry of a function with certain conditions and calling a certain piece of code if the conditions are not met. So we want that the stack is not empty, so we're guarding for that. If it is empty instead, we will then return a operand, and we return the 0 we talked about earlier. The second thing we have to guard for is for the first item in the stack, it should be an operand all the time, because if you have only an operator, we can't calculate it, so we will return a operand 0. So now this is our guarding stuff, and this is basically stuff that should not happen unless you're filling the stack wrongly. So for our recursion we need an end condition and we need the recursive conditions. Like with the factorial stuff, the I equals 0 returning a 1, and for all the other stuff the self-referencing call of factorial function. So our end condition is if stack count, so the number of elements in the stack, is equal to 1. We want then check if it's an operand, And if it's not an operand, but that should be actually guarded here, otherwise we wouldn't be at this place here. But maybe we can just remove this guard statement here. Just remember that this is maybe better. So if it's not an operand but an operator, we return operand 0. So that is basically the same as guarding at the start, but this way we have it all in the if stack count equals 1 end condition. And if the stack count, if we have an operand, we just return it. So basically, as soon as we reach a list where only a number is in it, we can say, okay, this is a result for this evaluation, and give it back to whoever or on whatever level we got called in this eval function. So, else, if there's more, we now do the look ahead stuff. So we get the operand. So first of all, one thing we should remember here, stuff that is put into a parameter of a function is always constant in Swift, unless you put a var up there. But I don't know, I think exactly. That was possible in an earlier version of Swift. It is not anymore in Swift 3 and 4. So the way to change the protective level of this parameter is to actually put it into a variable. So we define ourselves a variable stack and assign the constant stack. Now we can change the stack. What do we need to do? If you remember, we need to take stuff out and put new stuff in there. So the first thing we put out there, or take out there, sorry, is our operand. So the number, the first thing we need for our operation. And the operand is, I get this by calling the method removed first on the string or on the stack. So, and I want this, and I know it is, to be an operand. Otherwise I would just get a token here, and the token can do nothing. But if I say it's an operand, as operand, I treat it as to be an operand. And if that wouldn't be true here, if this as exclamation mark would say, dude, you're getting something from the stack that is not an operand, then there would be a crash. Oh fuck. Sorry. I think so. There was a little glitch. I think today is somehow not my day. So my shortcut didn't work for switching to the screen, or I hit the wrong keys. So I was busy typing and implementing, but nobody in the chat actually wrote something. So I was figuring that everything is okay, but it wasn't. I was on the pause screen and was talking and typing, and yeah. So this is what I've implemented so far. We have our struct, we have our static function eval, which takes a stack of tokens, returning an operand. We're guarding, like I told you before, we're guarding for the stack is empty. If it's empty, we return simply 0. If you remember our slide for that. If the stack is equal to 1, the stack count. The count is the length, the number of elements in there. We return the operand if it's an operand. If it's not an operand, We can't calculate this. We don't know what it is. We don't know what a list with plus is. So we return 0 if there's an error in there. And now we are at the else part of this evaluation of the stack, which is actually the case if we have more than one item in our list. So we save our stack in a variable, since this stack handed into the function is a constant. We put it into a variable to change it, and the first change we do is to remove our first element to be an operand. So if it's not an operand, this will crash, but we make sure it is. At least. So I removed this accidentally. We do have to make sure it's an operand, so we check it in our guarding stuff. Stack first is operand, else we return 0. So that's better. Now we are sure that the stuff, that this is an operand, and we are good to go. Now we have the look ahead. The look ahead is like the next token. We look at it, and this has to be an operator, and depending on the operator we do different stuff. So we get this and we call this next, and this is actually stack remove first. So we get the token, which is next to our operand, or was next to our operand, is now the first operand, the first token, and we get that. And now we are having our 3 cases. So the first case was if we can use our next token as a unary operator. So if we do that, we said that we want to evaluate everything instantly. So what we do here is we return our operator, so our unary operator, which can be a negate or a percent, call the eval function, and put in our operand, which we fished out of the stack before. Operand. Else, if this is our case, we do our multiplicative. We do the additive first because it's easier to write. So let's start with that. Else if additive operator, and we look at our next element operator and our next element and try it to be an additive operator. So this fails if that is not an additive operator, and it tries the next else block. The additive operator, we actually said that we use the operand and the rest of the list evaluated to do that. And here we have another, here we have a good recursion case. So we return additive operator, evaluate our operand, the stuff in front of the plus or minus, and the rest we evaluate, so we call eval, with the rest of the stack. So, and I actually looked at my notes, and I missed something in the unary part, because if I only would do that here, we would get a problem, because let's say we look at the first part of the list. It's a 10%. We see a percent sign. We create a unary operator for the percent and put in the 10 and return the result. Then we were done. But there is more in our list of tokens. So what we actually have to do is to return an eval of a list where the first element, or where the element is a unary operator evaluated with our operand. And this list here, because this is a one element list, we can now can use the plus operator on that list to add the rest of the stack. So basically that is what is in Swift 2. We take out the first elements, create a new element, put it back in there, and add the rest of the stack back again. So now we can go on with our evaluation. If you remember, we had this 10% times whatever plus 12 or so, I don't know. We then have the 0.01 thing, which is the evaluated, but still had the rest of the list in there. So this is basically what that does. So now we are coming to the last case, which is the most complicated case, which is, and after that we are basically done, if let multiplicative operator. So we check if our next S is an multiplicative operator. We will now get our second operand. So the second operand is the stuff behind the operator, and so what we are basically doing is let second operand be equal to stack dot remove first, because we removed the first operand, the operator, so what's left is the second operand. So remove that as an operand. It's basically the hardest part, because so the question is, why is this the hardest part? It's actually not that hard. If I just were to write it pretty simple, like I get this second operand like this as operand, and then I can now return the evaluation of, and we do this simply the same way as we did it in the unary way. We create a new element for the list where the multiplicative operator eval a and b is the operand and the second operand, and after that join the last part of the stack into it. It's pretty simple and it looks neat and beautiful, but we will run into some edge cases where this here actually fails. So in order to get these edge cases solved, we need a little bit more of a more couple of lines of code to actually make this bulletproof. So if we don't return statement up until now, we just return operand of 0. This basically should not happen because this algorithm up to this point is fully defined, but Swift wants us to have this here, and I could add an else statement here. That would be good as well, but doing it at the end of the function is totally fine in my opinion. So let's try this out and see if we can find the edge cases, and this will basically explain to you, Shinkai Soku, why this is the hardest part. It's not actually way much harder than the rest, but it's a little. So let's do some calculations down here. Okay, I don't have anything prepared for that. Anyway, let's just do our term stuff. So we define a term and we put an operand. Just a term. So we call our calculator .eval function, and we had our little list of stuff we want to get out of there. So we put in our empty list and see what it returns. An operand. Perfect. Everything is an operand. What's the value of the operand? 0. Perfect. So this is working. If we put in a operator there, like an addition, this should be 0 as well, because this is not evaluatable. It is. So if you put simply a value in there, like an operand, so we have this case in our slides as well, operand 5 should be 5. Okay, let's do a what is it? A unary operators. So unary operators, we add in the list, we add a negate after that. We had this example as well. And it returns -5. That works. If we do the negation twice, so just added another negate in the list after this one, we get a 5 again. The percent more 0.05. So unary operators work. Calculator eval. So now let's do a addition. Operator 5. Additive operator, not additive operator, sorry. Addition and operand 4. And I mistyped here. Like this. And the value of that should be 9. Works. If I do a subtraction here, here's subtraction. So there was a little typo in the code. So a subtraction is 1. Cool. Let's do a multiplication here. $20. Correct. And a division 0 times 0.25. So let's get our examples from the slides, the ones that we evaluated ourselves. So we have this here, put it in there. So let's see if that works. 5 times 265, and after that we do an addition with operand 12. And this is 1337. Works. Let's do it the other way around. We do 265, for instance, No, that's not working. 12 addition 265 multiplication 5. That's actually the other way around, and it gives the same result. Okay, let's go to the edge cases. Let's say we do a unfinished operation, and this can happen if you type the calculator. You're not always finished with the operation, but you always want to have a bulletproof result, right? So if we have something like like an unfinished multiplication, and we leave the last operand out, we're now getting an exception. So why is that? Because we go to this part of the recursion. We try to get the second operand. The second operand, the problem is that the second operand now is empty. There is nothing in there anymore. Okay, so what does that mean? That does mean that we get nil here. This is nil. And as soon as that is nil, we can't do the S exclamation mark, because that would mean that we want to cast nil to an operand, which is not true, which gives us a crash. So what you've got to do is, and that's where the lines are getting a little bit more complicated, is to do the following. Let second operand. Now we do an inline if statement. I think we had this last time. So if stack is empty, question mark, this should be operand 1. Why? Because if I write something like 5 times and stop there and hit the equal button, this should evaluate to still 5. So if I put in 1 after that, 5 times 1 is 5. So this is the identity value for the multiplication. Identity value means that everything that you multiply by 5 is actually the same value. N multiplied by 1, everything you multiply by 1 is actually itself. So n multiplied by 1 is n. So that's a good value here to solve this error. And if it's not empty, we will do as we always want to. We want to remove the stack remove first. As operand. Exclamation mark for now. Okay, so now you see this this errors stack evaluates to 5. That's good. So what if we have a list of this here, where we put a multiplication and hit the multiplication again? This is an error. Why? Because in this little case here, we just found one error case. So the error case is if it's empty. The problem is, if it's not empty, we are casting this to, we want this to be an operand. But what if it isn't? What if it's not an operand? We then have to do something else. So what we do here is we use as question mark. So the as, so use the token as an operand fails, this will be nil. And as you know, we have this double question mark thing that we can put into Swift to use another value instead of the first one if the first one is nil. So we can do double question mark after that, because the first one is nil in the error case, and add our other case, which is solving this. And as always, when we have an errorless, really errorless, and not just unfinished list, we will return a 0. So we put in an operand 0. So this here, operand 5, multiplication, should evaluate to 0. It does. Everything is good. We are all happy. And now we have that solved. So let's see if we have some unmanaged cases in our addition. So we have the operand 12 plus this, and let's get rid of the rest to really focus on that. So this works. What if I remove the second operand? 12. It works. Why? Because in our additive operator case, we remove the operand and the next, so we have an empty list there. And evaluating an empty list, which is done here, leads to a 0. So, and 0 is in fact the identity for addition and subtraction, because everything n plus 0 is always n, as well as n minus 0 is always n. So changed with our 1 here down for the multiplication and division, so we are good. That works. What is happening if we do this stuff with the multiple addition? Let's see if we have something here. Addition. That's unhandled. No, it's 12. This is something that's not really, it's not handled the same way as with multiplication. Maybe we should do it actually. Maybe this should be, not sure, maybe this should be a 1 as well. So why here? This is working because if we look at that, we get the additive operator, remove the operand on the operator, and have a list left where the first element is a operator. And then this guard statement saves us. Saves our asses. So good. This is working. And this way we can simply write long terms of our operators and operations and operands and put it in our eval function, and everything is good. So that's it for today, my friends. I am done. And I need other shortcuts. They're not working from Xcode anymore. Okay. So, what did we do today? We learned about recursion and loops. We really spent a great amount of time just digging into what is a recursion and how can we build one. Then after that we went our attention again to the evaluation of terms. We learned how a left to right parser works and what rules must apply to be LR parser. We digged deep on that topic again and really went through it a couple of times, and I hope that it was helpful and not too repetitive. And in the end, after some stream outage stuff and some problems with technical stuff here, we finally managed to write our calculator function in Swift. So I think that was the most technical we will get for the calculator. In the next session, we will actually do the connection between our calculator, our representation model, and our UI, and finally bring everything together so that we have a working calculator in Swift. Good. If you have questions, let me know. I'm here for a couple of minutes, and if there's nothing to clarify anymore, I would love if you like my stuff, if you like the way I explain things, or leave me a follow my stream. If you don't like it, leave me a comment, and otherwise I would be out, but I am in the chat for a couple of more minutes, answering all the questions you got. Thank you very much for watching, and see you next Sunday. Bye. Fourth session of us building our simple calculator, and today we finally bring everything together and use our mathematical representation, our calculator logic, and our UI to finally build the calculator. So this session will be without any lecturing, just diving right into the code and connecting the calculator with the UI. Okay, without further ado, let's try to get started. So, this is the UI we built in the very first session. I already started the simulator, and the one thing that's still wrong is that nothing works. So we're going to build our view controller class for this calculator. If you remember, the view controller has the task to manage its views and get the actions from the inputs, so from the buttons and all the other kind of components you can place, and display some other stuff and do some calculations, whatever you want, using the model or the logic, which is our calculator, and display the result to the user using some kind of other views. In our case, the label where the numbers are shown. In order to change stuff on the view, we need to have variables, or better, properties that reference our views so that we can access them from our view controller. When you start a new project in Xcode, Xcode will provide you with one view controller which is already connected to your view controller in the storyboard. Just saw that the chroma key is not working correctly, but yeah, so it is. If you look at your storyboard and you go to your view controller, you find up here in the identity inspector, you find the class that is connected to this view controller. And this is actually the same class as the view controller, which is started to getting implemented by Xcode here. So our first task is to give ourselves some properties that are connected to our label that we want to show some stuff in. So we do that by creating special properties, so to speak, which are called outlets. And an outlet is basically a connection from a view controller to its storyboard views or elements that you can position in the storyboard. So Xcode provides it by default. Yes, the first view controller, if you start a new project, will be provided, but you can of course add new view controller classes and add new view controller elements to your storyboards. So because we just have one view controller in this little app here, we won't cover this here, but I think maybe I will do another project which will encompass or incorporate more than one view controller, and there we will cover that. So let's start with creating an ordlet. There are different ways to create ordlets in Xcode. One is a pretty simple way where you just have a drag and drop solution, which I show first, and later I will show another solution just by writing the code oneself. So to do the drag and drop selection, you can change from the normal view and to a assistant editor view, which brings you two columns of content in your Xcode. I just hide the left and the right bars to have a little bit more space, and the bottom bar as well. So just by these three buttons here, you can toggle the views. And I will now go over and select up here what I want to see in my assistant view. And there's one really interesting things. Let me see if I find it. Sometimes this is a little bit messed up, so it doesn't always show me the stuff I want to have. So let me just see if I can figure out what he's now having a problem with. Siblings, superclasses, counterparts. I was hoping for the storyboard to pop up in here, and this is actually not really helping. So if that happens to you, one good way to open a different file in the assistant view is by holding the Alt key and clicking the stuff you want to see. So you hold Alt and click on main storyboard, and then it shows up. So that's what I was looking for. That's what I wanted to have. So getting rid of that here, and now we want to have a connection from this view to this code, and we do this by selecting the element we want to make a connection to. You can do it here as well. This is the view hierarchy, as you know from the first session. You hold the Control key and you drag over to your code, and you see this line appearing, and you let go, and then it tells you that it wants to connect an outlet, which you want to. You can give it a name. The type, like the data type, is a UI label. That's the class of this element. And storage weak, we leave it that way. This is another would be another topic that would bring us too far away from our main purpose right now. So leave it to weak. That's in most cases that is correct. And then we give it a name. So I like to give it a name where I can read out what kind of view it is. So it's the display, and it's the display label. So connect. So the question is, what's the storage for? Storage basically has a couple of different, let me just do this again, different properties here, weak and strong, and it basically means how can I make it quick? So weak means that the link we're producing here is not preventing the view controller to be thrown out of memory, basically. Or, sorry, I got this wrong way. Weak means that the label can be deleted from the memory by some other system, the UI system, without our view controller clinging to it. So that's important. If your view controller goes into background, the iOS operating system basically cleans off a lot of the views to make space in the graphics memory. So as soon as you bring the view controller back up, the system behind everything will make sure that your views are in place. But if you put it too strong, this link would prevent the operating system from cleaning off or cleaning out your views, which might or might not be really useful. In most cases, if you're dealing with views and outlets and storyboards, weak is totally fine, and the rest will get managed for you. So now we have a variable where we can access, and there are different predefined methods here. So one is view did load, and one is did receive memory warning. So this really quick, we don't need this, so I can delete it, but before I do it, did receive memory warning gets called when the iPhone runs out of memory. So it gets called for all the running apps, and the apps and the classes or the view controllers that are currently in action can now discard some of the memory they allocated because, I don't know, some caches or whatever stuff you have. And here you can get rid of it, so you make free for other apps of other processes on the iPhone. If you don't do that and your app is one of the most memory consuming apps, it will get killed by the operating system. So since our calculator has so much different cache stuff and lots of memory hanging on to this view controller, we just can get rid of it, and if we find that we need it later, we can just put it in there again. Okay, so view did load. View did load is a method that gets called as soon as your view controller is ready to be shown. It's not on the screen yet, but it's ready to be shown. So view did load means that all your views are already in the memory and all your connections to the views are already in place. So you have to think about that. There's a loading phase where the views get set up, where the class for the view controller gets set up, and then they get connected. And view did load is called as soon as this connection is in place. And this is the time where you do some additional initialization for your views. For instance, we can try out now. If we have our display label, we can set a text on it and see if it changes when we recompile and start the calculator. So we just go self display label dot text equals to hello world. Then I go Command R for run, or hit the play button up here. Wait a couple of seconds and hopefully we'll see a calculator saying hello world. So that worked. So now you see that we have a connection from our code to our label. So this makes no sense, so let's get rid of it. Okay, so what we want to do is, as every time a number is touched, so that's our first step, we want the number to appear here in the display label. So there is another kind of connection between view controllers and the storyboard. The first was the outlets, and the other one is actions. And actions are specific methods that you can assign to certain actions that are done onto the views. So if you have a button, there are a couple of actions that you can say, okay, when this happens to the button, but please call this method, I want to do something. So we need a method here which gets called every time we tap a button, a number button. So we just go on with that for now. So we can do that the same way as we did it with the outlets. We go in here, we hold Control, we put it on in here, and then we change the connection type from outlet to action. And we give our method a name. I call it number touched. And we then can specify what kind of parameters we want to have. So we can say we want a parameter. So like arguments, like parameters is the same as arguments. We can say we want to have the sender of this, the sender and the event. So who's done action to and what action is it? Just who's done action to or nothing. So we want to have the sender because we want to know on which of the numbers button the user touched, and we don't want to have a separate action for each of the 10 number buttons. So Wetrix asks, what is an outlet? One moment, I will come to that in a second. Let me just finish the action here. So we go in, we want to have the sender, so on what button we touched, and we want it to be of a type UI button, because these are all buttons. Connect. So now I have a IB action. IB stands for Interface Builder, which is basically the old name for storyboards, like really colloquial speaking, so it's not really precise, but it's like this system here. And every time I now touch on the 7, this method gets called and something happens. So let us just test that. So I do a print, which lets me put stuff here on the console, and I just put in 7 touched. So I run it, and we will see if this appears in the log when I touch the 7. And there it is. Every time I touch the 7, this appears, so we know as soon as I touch the button, this works. Good. So before we go on, Wetrix asks, what are outlets? So outlets are basically connections from the view controller to the storyboard. In that case, in that sense, that we define a variable which holds a reference to a certain view. In our case, we have this variable display label of type UI label, which is, after the view is initialized, this label here. So everything I do to this variable in my code, like for instance, as I showed before, setting display label.text to hello world, will affect the view that was set up in the storyboard. So if you look here, you see when I touch this and go to the identity inspector up here, this blue thing, you see that the class is UI label, the class, the data type. So this matches. And when I go here to connection inspector, you see there's a referencing outlet of display label to view controller. So this goes to this. So this goes to this. So this is how this plays together. I hope that makes sense. So now we have the 7 touched. So, but we want to have that for every different button. So we could go on and do this here. And go in here and create a new action and go in like, I don't know, 8 touched. And we put in the same stuff and here and everything. And now we could do something for the 8 touched. And we could do that for all the buttons, but that would be pretty lame. So we will remove this and make sure that we also remove the connection. So if you go in here and you see here 8 touched, and this is actually, if you run that, this would crash the app because the method is not there anymore. So we can delete that. So we should delete that. So what you want to do instead is that you want to connect all of these buttons to this function here, this method. So we can just control drag and control drag and so on. Okay, now you see we have connected all of these buttons to this one method. So if I run the calculator now and I can touch any of these buttons, this little print message should be shown. So here we go, down here. I have to hit the 4, 7 touch, 6, 2, 3, 0. Okay, so every Yes, all numbers the same line of code, but the numbers are, the line of codes actually are wrong right now. So let's get rid of that. So of course that makes no sense. That was just for a little bit of a demonstration here. So what we want to do is now we want to figure out what kind of number we touched and want to add it to our little label here. I know already how this turns out, so I will add a new function which will do the adding of the number, of the digit. So I have a private function, add digit, and let me just look, and this is actually like, let me make this string. So we have a function which is add digit, and we want to set the display label text. We want to change that to be we want to add the numbers we're typing to the display label. So we have our variable here, display label, and we want to do stuff depending on whether we have. So let's do that step by step. We set the display label text to be the digit we just entered. If the display label text is not 0, we will text append. Plus equal is an operator, which is basically a short form of display label text plus digit. If you remember the second session we did, you can add a string to a string, and this way you can append one string to another. So this is your interesting error, which we have to figure out. So if we look at this, so the display label UI label has a text property, and the type of the text property is actually not shown to us, but I know it's a string optional. So it's really like telling me, okay, either you know that there's something in this display label text, or you better find a way to solve that if there's nothing in there. So we know that there's always a 0 in there at least. So we can just put in a exclamation mark, which will unwrap the optional if you remember session 2. And this way we have a string plus a string and not a string optional plus a string, which will give us an error. I hope that makes sense. Let's see if that works, at least a little bit. Oh, sorry. I was a little bit getting ahead of myself. So we have this function here, but we need to call the function, of course, every time a number is touched. So we get the sender here, which is the button we touch on. And we know that the button we touch on has a title, and the title is equal to the number we touch on, because it shows the number, right? So if I have the sender and I go to title, like here, current title, I have the 7890 whatever. And if I now call my new function add digit, which is the current title, I then hopefully have the first little step towards a calculator. 7, 8, 9, 5, 6, 2, 3, 0, 0. So nothing else is working, so I just okay. So if I type 0, okay, nothing happens. That's good. Comma, nothing happens. 3, 2, 0, 3. So that seems to work pretty well. Good. So we can type time. So for now only numbers work. Yes, for now only numbers work, because we haven't added the other buttons yet. Okay. So we can add numbers here. We can add another simple button, which is the AC, so the all cancel button, which just resets the display to 0. So in order to do that, I showed you the method of control dragging the button to the code. Another way is to just start writing IB action func all cancel, that's AC, touched. And for this method, I don't need to know which button it was, because I know it's always the all cancel button. So I just give myself no arguments here. And in there, I will do self label display label text equals to 0. And now I have a method which is not connected yet to the button, and I can now go from this little thing here and drag this to my button. And this is another way to connect it. Yeah, sometimes so much easier to just point and drag. Yes, sometimes it is. Other times it's not. If the storyboards are getting really big and really slow, it's sometimes a little bit more easier to just write out your functions and later connect them. In this case, it's so small, everything is good. So if I hit this, nothing happens, of course. If I type something in and hit this, it gets reset to 0. So basically what we can do now is not much. We can just type in numbers and clear them. So now let's get back to a little bit more interesting stuff here. What is good? Okay, so if you remember correctly, we have our calculator, which I haven't yet put in here. But we created the calculator last time in our storyboard, in our playground. So I really quick opened the playground from session 3. Here it is. Open the playground up. So that is what we did last time. And I need exactly all of this. I need the calculator, I need our mathematical representation, and I will put this simply by copy pasting it. After we tested it in the playground, I just get this and put it inside of my project. I will create a new file by selecting the folder I want to create the file in. Tab new file, Swift file, next. I call it calculator, create, and put this in here. So now we have the calculator and everything should be fine. I think we have oh yeah, we have a git here. So let's do some committing. So in order to have a good progress of our project, we need to do some commits here and then so that we can go back. And for this little project, I wouldn't need it, but most of the time I have a git in the background to do my source code control. Like we set up in the first session, I guess. So the first thing we did was we connected our display label, added the number touched and the all cancel touched, and added the add function. So we added a basic entering number functionality. Suck. So next we add the calculator class, added the calculator logic class. That's our class, calculator logic. Okay, so everything is committed. Let's go back to our view controller. So if you remember from our calculator, what it does is it evaluates a stack of tokens. where tokens can be either operands, so entered numbers, or it could be operands, so plus, minus, divided by, multiplied by, you know what I mean. So now we have to figure out a logic how we can implement the typing in numbers and put it into our calculator logic as operands. So an operand is basically separated, and I showed that a lot in the slides with the examples we did, by hitting an operator or hitting the equal sign. So if you type in a formula like 2 multiplied by 5, you tap on the 2, hit the multiplied button, and then we know, okay, the 2 is our first operand. Multiplied, the first operator, and 5 equal, 5 is the second operand. So this is how we can discern between entering numbers and saving them to our calculator logic. So let's do that. Let's add a function here before we add this to our actions and stuff, which we need to do. We will just start with a little helper function, which is called add operand. So this function is basically doing if self.displayLabel text question mark is, so we know it's never empty. So if it is not empty, so basically we're calling the isEmpty method on the text in the label, which gives us true if it is empty, and we negate that with the exclamation mark. So everything with an exclamation mark in front is negated, so true becomes false, and false becomes true. So if this here is true, so basically if it's not empty, we do this here. And we will do the following. We will type calculate. So, okay, I missed a step. In order to do that, we want to call on our calculator the add with an operand of our self-display text. So that is of course not working, and it's not working because we did have to do a little more work here, but basically that is what we want to end up with, more or less. So the first thing is, of course, we don't have a variable calculator by now. So what we have to do first is give ourselves a reference to our calculator. So we don't need that because we don't need that now. We will need it later. So, but for now we could just call eval on our calculator because it's a static method. So we don't need to have an object of the struct or an instance of the struct. We can use the struct itself to call the static method. So this would work. But now there's another thing that is wrong. We don't have a method add operand. So the thing that we missed here, or sorry, the thing that we haven't implemented yet is we only have implemented the evaluation of our calculator last time, but we haven't implemented all the management of the stack and all the other stuff that the calculator should do. So let's do that now. Let's say we want to have our calculator to have its own stack. Then we could give it a variable, a private variable, which we call stack, and that is of type token. So here we will store all the stuff that we enter into our calculator UI. And we could just make this public and let the view controller write calculator.stack, add stuff and do that. But this is not a good practice. We want to encapsulate our private variables and have it been in one place. Sorry, we want to encapsulate our private variables and want to have method that access them and manipulate them. So a question, what's the stack going to be used for? When we're typing our formulas into our calculator, like this 5 times 2, we want the stack to hold the 5, the multiplied by operator, and the 2, that we can then evaluate our result. So the stack is basically the memory of our calculator, where the different calculation steps are going to put in, which we put in the end into our evaluation function to get the result of the current stack. But I think that makes more sense if we just move on, and hopefully in the end it makes all sense. So we have our stack, and we have a couple of methods there that we're going to use. The first is that we want to add operands to our stack, and or not just operands, more like tokens. So we need a method that adds a token, so one piece of formula to our intern on our calculator memory, our stack. So we need a function, and all it does is adding a new element to our stack. Stack append or stack append, sorry, new element. So token. So that way we can put a operand like a number or an operator in there, and it will work. So now we get this error which we've seen before. That's because we have a struct, and structs are, as I said in lecture or in session 2, immutable. So they can't be changed normally. So they just get copied from one instance to another, or they just get copied and then you can use it and give a copy to the other one that can use it. But if you want to change something, you want to change the copy itself, you have to have special rights for that, and you have to define functions that can do that. And for that we have to say that this sorry, not mutable, it's a mutating function. So this function can mutate the calculator. But of course, sorry. So like this, mutating function. So now our function add can actually add something to our stack. So, but this won't work, still don't work. Even though our calculator now has a method add, this is not a static method. This is a method that can only be called on an object of a calculator, so that it has its own stack. Otherwise we can just call the eval function, because it doesn't need this stack. It just uses whatever stack we put in there. So we need a calculator instance. So that is our first time that we declare our own variable, other than just having links to our storyboard. So in the first step we have our outlets. So this is a fancy way of defining little comments, which will add a little separator here in the drop-down menu. I like to do that. So we have our outlets, we have our life cycle. So everything that gets called in the life cycle of our view controller goes in here. We have our actions, just cleaning up some stuff here. And we have our, I call this helper for now, helper methods. So now we have it all nicely with helper, actions, lifecycle. The next step we have our state. So, and the state is basically the stuff the view controller needs to make decisions based on the stuff that comes into the view controller to make decisions on what has to go out. So one of our state here is our calculator. So we give ourselves a private variable calculator which is actually a calculator. Calling this here is the constructor of the struct as we had it with our persons and jobs in the session 2, and it gives us a calculator. And it wouldn't give us one because we didn't initialize the stack correctly. The stack has to be initialized with something. Or maybe we need our own initializer method, which is totally fine as well. See? No, okay, that worked. So now we have our calculator variable here, but there's still something wrong, of course. Operand is not convertible to calculator. Yeah, that makes sense, because we call it on the struct right now and not on our variable. So we have to do a lowercase c calculator, and this won't work because now we have a string in here, and this is a double, and we can't put a string into a double, so we have to figure out how to make a number out of the string.
And reappeared.
Okay. So it's pretty easy actually. To make a number out of a string, we cast it to a double. So this doesn't work every time. So if I put in a string like hello world and want to make a double out of it, that's not a number. So how should I know what kind of number I want? So double is a number, so it doesn't work every time. Even though that we know that it should work, we have to figure out a way to give a workaround for the case that it doesn't. So we get a double optional here, and with the double question mark we know that we can give an alternative value if the first value is nil, and so we just give it a 0. So if we can't figure out what the display label text is in terms of a number, we just put a 0 in there. So now that we have the add operand method, we can now use the different operators to actually end the input of the operand and put the operand into the stack of the calculator. And we can do that For instance,
and reappeared.
when the equal sign is touched and when the operator is touched. Yeah. Let's do it with the equal sign first. So we are here and we want to have our view controller and our main storyboard open side by side. So I clicked on this with the Alt key hold down, and now I will give myself a new action down here, which I call equal touched. And I don't need to know who's the sender, so I can send no in here, connect, and I get myself an equal touched method. So every time the equal is touched, we can just call our add operand method. And the interesting part about that is we won't see anything if I run it, but in the back of everything we can see that it will be added to our stack.
His head disappeared.
If I would add a method to show that. So let's see.
And reappeared.
So nothing happens. So let's just so that we just see that it's happening, let's print our stack every time we hit the equal button, or every time we add a token to it, so that we can see it in the log down here. So 9 equals, okay, simple calculator, operand value 9. 6 equal 9, 9, 6. 5 equal 9, 9, 6, 9, 6, 5. Okay, of course that's stupid, but now we see that we adding up operands. So, okay, that seems to work. So let's add a new commit here. For this, added a internal memory stack to the calculator and a method to add some tokens. Okay. So what we want to do now is we have some other stuff. There's a lot of stuff to do actually. And just figuring out what is the best way to go about it so that it's making sense to follow this. So let's go on with the operator touched. I think that's the best way to go, and all the edge cases that we have to figure out, we will do that later step by step. So there's a lot of little nifty edge cases that we will encounter along the way. So we just talked about it. Every time we touch an operator, like one of these or the two up here, we want to end the input of our operand and add the operator onto the stack, the operand and the operator. So here we want to have a method that is basically almost the same like this one. So another way of creating a method is just copy this, renaming this into operator touched, getting in here and connecting all our operators with the code. And we use the same method as we did with the numbers. We read out the title of the button and with that distinguish the different operators. So every time we hit an operator, we will add the operand to our stack. So we have that already figured out. So we just call add operand. Okay. And now we have to decide which operator should be after this operand in our memory. So for that, we will use a switch statement where we use the current title of the button as deciding factor. In case I haven't mentioned a switch statement, you can think of a switch statement as a lot of if, else, if construct. So basically, we will decide to use a additive operator if the current title is equal to plus. And if it is, we will do calculator add addition. Okay, so let's do all of this. If the case is a minus, we will add calculator add subtraction. If it is the division sign here, we have to get that out of the interface. If it's this little thing here, then we add a division. If it is a multiplication, that's not a simple x, so that's why I get it from here. I put in the calculator add multiplication. So that were our binary operators. Now we do the two unary operators. First we can do the plus minus or negate operator. Negate. And we can do the percent. I think it's a default percent sign. So like this. And we add the percent. So this way we have now all our operators are now added to the calculator, and we are good to go and to see if our stack is actually adding all the stuff in our to our calculator memory. So switch must be exhausted. Yeah, okay. So the switch statement actually has to deal with every case that we throw at it, and we have now a set of 6 different strings that we handle, but a string can be everything. So we have to add a default case which gets handled every time we throw something at it that it can't handle. And I will just do that by printing a message which says unknown operator, and yeah, just put in sender current title there. So that's basically a error handling. So every time we get an unknown operator, it will just print out unknown operator, and whatever we throw at it, it will just show us. So all the other stuff is handled. Let's run this and see if our stack gets filled with operands and operators now. Okay, hitting a 2, sorry, hitting a multiply by. So now we have in our stack, the last thing we see is a operand value of 2 and a simple calculator multiplication. Okay, cool. So then we will, what's that basically here? Anyway, Next I will minus 6 plus 2, so whatever. So we have 2 multiplication, operand 2, operand 26, addition. So that looks pretty dumb. Why is that? We have a little problem here that we're gonna need to fix in the next step. So Starlord91 asks, what are the what are the examples that this switch can't handle? Pretty simple. Every string, every button title that gets in here, which is not plus, minus, divided by, multiplied by, plus or minus or percent, so everything we didn't specify here is actually unhandled. So if I do a button where, I don't know, hello is the title, then this switch statement doesn't know what to do. And in that case, it will print out unknown operator hello. So let's go back to our little problem here. So I hit the 7, I hit the multiplication. 7 multiplication. Okay, I hit the 5. Okay, so I don't want to have 7, 5 there. I want to have the 5 there. That's one thing. Then I hit the plus. So I get 7 multiplication, 7, 5 addition. So somehow the stuff that we are inputting is not always the stuff that we see on the display. And we have to make a little distinguishing between our inputs. So we have to make a little distinguish between our inputs and our actual display value. So what do I mean by that? I want to have a new variable, a new state variable, which is a input string, which holds all the digits and all the string stuff that we put into our calculator. So which is shown at some point in the display, but not always. So I initialize this with an empty value. So instead of putting in a digit, instead of putting the input string directly on the display, I want to also add it on my a digit. I want to add it also to my input string. So input string, that guy's input string plus equal digit. So now I have a variable which keeps track of all the stuff that I enter into the calculator in terms of numbers. And then I want to set my display label just to input string. So every time I enter something, I add it to my input string and put the whole input string into the display label. So it seems like a little bit of overhead right now, but in the end I promise you it will make sense that we did it that way. So in every time we are now adding an operand, I want to reset the input string. That way I don't lose what is shown in the display, but internally I know, okay, now I'm starting a new number. So what we do is we add the operand to our calculator and reset our input string to an empty string. So if I start this now, I can now type 7 plus 5 minus 3 equals. So now I have a good and clean unknown operator minus. Let's see. Let's see. This is a case it can't handle, and I know why. The problem is that this little dash I put in here is not the proper minus sign I used for the UI. There's a minus sign that's a tiny bit longer than the normal dash. So that is what I used here. So in order to fix that, I have to copy this string from here to there, and yeah, it doesn't look any different actually, and maybe it was a little bit of over engineering here. But if I do it now, this should be working. So if I do 8 minus 2 plus 6 divided by 7 equals, I have now a pretty clean set of tokens. So 8, subtraction, 2, addition, 6, division, 7. So exactly what I typed into the calculator, we have now recorded into our internal memory. And this, ladies and gentlemen, we can just put it into our evaluator and get a value from it. So let's try that. So every time we add something to our token list, we actually can actually evaluate the real value of the current calculation. So if you remember how a calculator works, you type in 2 plus 6 and it shows you 8 if you hit the next operator. If you hit the next operator like minus, it will show you the 8, I think. Or it will show you instantly. That's something that calculator. So if you go on this calculator, which looks pretty simple, like so if you do it here in the Apple calculator, we do 5 minus 3 times 9 equals minus 22. Okay. 5 plus 3 plus and here we go. Every time I hit the plus, it actually shows me the value of the stack. So what we do now is to evaluate the stack every time we add something to it. We can do that pretty simple by returning an operand, so like our eval function does as well. And every time we add something to the stack, we will call eval stack. So and return that. So every time we add something to our calculator memory, we get the immediate result back. So we have to write calculator eval because it's a static method. And so every time we are adding we're returning, let me just do something different here. Let me just see what I did as I was planning for that. Yeah. So everything that comes out from our calculator, we can just let it be a double. Because we know that it should be an operand, and each operand has a value, like if you see here, where is it? Operand value double. And we can use this to return the double value of our current calculation. And this way we can, every time we add an operand, we can update our display label up there. So this is, I think, how we can actually calculate stuff. Let me see. So our display label dot text should be equal to string of a double value, which we return from our add operand function. So that looks pretty long and pretty ugly, and we will really clean that up later. I really wonder how hard it is to make an advanced calculator where you type whole equations. Actually, from that what we have now, it's not that hard anymore, because our calculator in the back of everything, we keeping a whole equation, and at any point can evaluate it. So if we would add some little bit more tricks like brackets, I think, and a little bit more operators, I think we can turn it into an advanced calculator pretty easy. So let's see, if I type a 4 equals 4.0, that's good. 5 equals 0. Why? Because we have now an invalid set of rules here, which is that we have an operand and an operand, but an operand is not an equation, so we can't simply say what it is. That is something that we're gonna fix later. So if I restart this or hit the all clear button, no, that wouldn't work because we haven't really implemented that yet. So when I go here and type 7 plus 6 equals 13. Works. So why can't I just go with minus now and do 6? I can. 1. I can't start a new calculation because we haven't implemented that yet. So every time I just going from operand to whatever, 9% plus 3 equals 0. Why? Operand, percent, operand, addition, operand. So we have a lot of little side cases here which we didn't really got right now, but we have a really basic calculation here. If it goes 20 plus 6 minus 2 times 9 divided by 8 equals obviously 3.75. So what do we have now? Little recapturing here of little recapturing. So what we do is we have our let me just put this here. So little recapturing of what we did already. We have our number block, our equal sign, and our operators. And every time we type a number, we build up a string, an input string, which is this numbers. So we have like 789 versus 789, and as soon as we hit an operand, we add an operator, or the equal sign, we will call our add operand function. And this checks if the display label is not empty, and if it is not, we will use the stuff that's in the display and put it in there, and then after that set the input string to be empty again. So that is a little bit clunky here, because we could just use our input string, which is basically the sequence of numbers we typed, and check if that is empty. So we go in here, put in if not input string is empty. And then we can go in here and say we want the double of our input string. Good. So that looks a little bit better. So after we did that, we do now have this operand in our list. And if we added an operator here, we do this too, and as well add a little addition, subtraction, multiplication, negate or percent operator based on what we did. So let's make this a little bit cleaner, a little bit more swifty. And I think then we have it for today, and all the other stuff, all the edge cases we'll cover next time, hopefully. So we have our input string here, and what we do a lot is that we get the input string and we cast it to our just see if we do it a lot really, but we don't. Anyway, we cast it to a double, and another way to do that is to implement a property, a calculated property. So that's a good example for that. So we can define our own variable, which is called input value, and this is not actually a variable per se, it's actually a little function that gets calculated every time we access this variable. So we do return double of our input string if it is possible, if that is actually a string that's convertible to a real number. Otherwise we return 0. And we have to say that we want to have a double here. Not calculator property, sorry, a calculated property. So instead of giving it a value like we did here, like empty string is the value and we changed that, we have here a little rule which defines every time we access that property how we calculate it. And we use a little bit of snippet of code that transforms this input string into a double if possible, otherwise it's 0. So we can use this now instead of this down here. Instead of doing this in here, we can now use input value. So this looks a lot cleaner already. So we now see that we have a calculator which we add, where we add an operand from our input value, which is basically the input string as a double. So, but there's more that we could do. Let me just see. Okay, we have now our display label text equals string of blah blah blah. So what we can do now is we can add a calculated property or a setter and getter property, which actually gives us a cleaner way of writing this. So we could define our private variable display value, which is the same as a display string, but it's a real value, and it's of type double. And every time we set something there, so every time we write something into the property, we can instead run our own code. And we want to do self.display label.text is equal to string of the new value. And if we read out from this property, from this display value, we want to return a double from our display label dot text or 0. This actually is never called. We don't use that because we have our input string and input value, but I have to implement that because otherwise I couldn't use the set stuff here. So the display value basically does the same as all of this here. So we can write this much cleaner and say that our display value, the stuff that is shown in the display, is the result of us adding the operand to the calculator. And that, I think, is a lot cleaner code and a lot better to read. And now we can do this, and that's why I did it before. Every time we add our operator to this, we actually can do the same. So we can just write display value is equal to whatever the calculator tells us the new value of this stack is after we added the operator. So this way we get rid of these warnings. Let's try that out. 8 plus 6 minus, and that looks pretty shitty actually. Minus 8 equals 0. Why? Because somehow I started with an addition, which is pretty stupid. Eight plus, why? I did mess something up here. Yeah. So what went wrong? The first operand didn't get added to the current stack. That's because I made a mistake. I only added stuff to the input string if there's already something in the if the displayed label is not nil anymore and not null anymore. So I have to do set the input string to be the digit first, and after that I have to set the display label text to be the input string. So what I see now here is that this and this is the same in both, so I can just put this down here and remove this, and this looks cleaner already. So now if the display label text is 0, we set the input string to digit, else we append the input string a digit and then set the input string to display label. But one thing I ask myself is, if I would read this code, and I haven't wrote it yet, if I would read this, I would ask myself, why is he using display label text up here and then just manipulating input string? Why can't he make the decision if he wants to set the input string or append to the input string based on the input string? And actually we can. We can just check if input string is empty. We can do that. We can do that. Let me just see something here. Okay. So if I run that now, I just introduced a new bug on purpose, but it's this one. I can now type zeros, a lot of zeros, which is stupid. But if I go on and type 7, okay, let's just restart it. There's a lot of bookkeeping to do later on. We're going to type 7 plus 6 minus 5 times 8 minus 3 equals. So this actually looks pretty much like a calculator already. Even though that we have a lot of problems with, like if I go on here, go again, or type plus, oh, this works. Let's see. Let's get it to okay. So it's not really changing the value anymore, and the stack we're building up is pretty huge and pretty wrong. So actually, what we need to do in the next session, we will add stuff for entering decimal numbers, which we haven't done yet, and we will actually add some new function which is reduce, which reduces the current stack to just one operand, so that we can calculate with that on and keep the stack to a minimum level of complexity. So let me just see if there's something I missed. We will also do some number formatting next time. But other than that, I think we have a pretty simple calculator right now. Okay. Thank you very much for joining. I hope you found this interesting, and it wasn't too fast or too chaotic with me. I will upload the file which we just created right after the stream, so you can play around with it. And yeah, I hope to see you next time. And until then, have a good night, day, or evening, depending on where you are right now and from where you're watching. Bye bye. Hello everyone. I hope you're alright. It's time for another session of building the simple calculator in Swift. So, without further ado, let's dive into the code where we left off last time, and let me show you what we have already accomplished so far and get on with implementing the rest of it. So, as you can see, this is Xcode. Let me just quickly run the calculator for you to show you what we have already done so far. So here we are. This is the calculator so far. The UI we built in the first session. And after that we implemented a mathematical representation for storing mathematical formulas in Swift, which we can then evaluate to get the right result. The evaluation we implemented in session number 3. And last time we started with connecting this UI to this calculator logic. So let's try out what we can already do and what we still need to achieve. So typing in numbers works as expected, as long as we don't try to add a decimal here and adding fractions of numbers. Adding a number to this, like +1, resolves exactly to the desired result. And as you can see down here, we have still a print statement for our chain of operands and operators, which we put into our calculator to evaluate the mathematical term. So we entered this number 79654, tapped on the addition symbol and tapped in a 1, and the result of that is 7896550. So this works if I add -1, this works too. If I divide this by 5, works as well, and times 5 gives me back the original result. Minus and negate is not really working. We will figure that out in a second. And percent is not working in this configuration as well. So there's a lot to do for us, and the first thing I want to do is to add a reduction function. What do I mean by that? So in certain cases, when we hit the equal sign, for instance, so let me just test, is this already working? No, it's not. So the AC button, the all clear button, is not working because we're not clearing our calculation stack. That's the name for this number of different operands and operators we have in our calculator. We have to erase that as well when we tap the AC button, and not only reset the label like we do right now. So let me just restart the calculator to make my point even more clear. So there's a question already. Are these functions that don't work hard to implement, or is it something else a problem? So without spoiling too much, it's not really hard to implement them, but we need to understand some little concepts here, which I try to walk you through step by step, because we don't have brackets in our calculator syntax, so that we can say, okay, all of this term should be applied to this negate or this percent operator. We need to reduce the term to one single number before we carry on with the evaluation. Same goes when we hit the equal sign. So if I type 5 plus 6 equals 11, we have still the full list of operations down in our stack. But I'm now trying to add a single point or a binary operator. It will only be applied to the last part of the list. So if I hit the negate button, -1 is the correct result, but it's not intuitively correct because we thought that we have the 11 and we want to put a minus sign in front of it. So instead what we have is now 5 plus minus 6. So this is where the reduction to one number comes in. If I now do plus 3, this works, but I think this shouldn't be working in every case. Let me just test something out. Maybe we go 3 plus 6 equals. So if I start now with a new number like 6 minus 3, we get a 3, which is totally correct for the last part of the equation. But if we look at the whole part of the whole equation, we see that there is something like 3 plus 6 is 9, which is completely ignored right now. So let's start by implementing a reduction function to get the unary operands to work. So what I mean by that is I want to have a function which I call just reduce, and which only purpose is to take the current equation in the stack and reduce it to its result. So in order to do this, I need to mutate the stack, and because we are in a struct which are per default immutable, we need to define a mutating func, and I call this one reduce, and it should return nothing. It just changes the stack, self.stack equals, and we put in the calculator eval function. We use that to get the result of the current stack, which is a operand, so just a number. And because we have a stack of tokens in here, and operands are token-like operators, we will put these into a list. Just by putting the square brackets around it, we can construct a list like we did if we do something like this. For 3, 5, we have a list of these integers here. We can simply put in the return value of one function, which is in our case the calculator eval function, where we put in our very own stack. So this is all that we need, and if we call that, we take the current stack, reduce it to one number according to this formula that is in there in our eval function that's evaluating this, and putting it back into the stack. So let's give this a little build to see if we don't have any thing wrong here. So there's another question. Weetrix asks, tokens work the same as operand? No, they don't work the same, but they share the same parent type, if you want to say it like this. So if you remember session 2, where we implemented the structure for our representation, we said that everything that we want to store in one mathematical equation is a token. So, and a token can be an operand, being a number, or an operator. So an operand is just holding a value, and the operator is holding the type of function that we want to apply onto one or two operands. If it's one operand we want to apply the operator to, we call this a unary operator, like the percent or the negate operator. Or if it's a binary operator, we have this multiplication, subtraction, addition and division operators. And every operand, like you see here, is a token, like every operator is a token. So we can put these into a list of tokens and can then distinguish them by asking Swift for the right type, like we do this in our evaluation function. So if we can use the current or the next token, so we get the next token here, and ask Swift if it's being interpreted as a unary operator, as an additive operator, or a multiplicative operator. So this is how this relates to each other. I hope that helps. Otherwise, please feel free to revise the stuff on the slides for session 2. You find all the slides in the resources download folder, or just simply rewatch the video. Maybe that helps to clear this even more. So the reduce function is ready, and now we have to add this reduce function to a couple of our methods. And one method I want to add this to is the equal operator. So every time I hit equal, I want to dense or simmer the equation down to one value. So, of course, Retrix. Always glad to explain stuff again, but I think you can relate that going through this in much more detail would prevent us from moving forward in this session. So we are in our view controller where we do the connections between our UI and the actual code and the management between what we put into the calculator logic, getting the values back and showing the right stuff to the user. So we have this function equal touched here, and instead of just equal touched, which ends the entry of a new number by calling the add operand function. So if just to refresh this, we're typing in a number and the calculator has only two ways to know that we are finished typing in the number. And the first way is to type on an operator, because we know, okay, if we're typing in a number and now comes an operator, the number must be finished, or if we hit the equal sign. So typing 5 plus 6, you can't tell other by us touching the equal sign that we are not going to write 600 or 60 or 65. So we're adding the operand, and after that we call calculator, our own calculator reference, reduce, so our newly implemented function. And when I run this now and type in an equation to the calculator and hit the equal sign, like 5 plus 6, and hit equal, you will see that you will see the last stuff that I entered, but actually you won't see the current changing, because I didn't add a print stack after this one, and I just want this to have there because I want you to show that this actually works. So what we're expecting is a single value in our stack, which is 11. So as you can see here, we type in the 5, tap on the addition operator, add the 6, and this all simmers down or concludes to 11 after we hit the equal button. So that works. This is also necessary if we want to have the unary operators to work correctly. So typing in 5 plus 6 and hitting the equal sign works, because if we type now the minus here, now this negate is actually applied to our 11, so we're good. Let's try another example here. Other things is like if I want to write 5 plus minus 6, I write 5 plus 6 minus, and this actually works as well. So 5 plus operand 6 minus is 5 minus 6, which is minus 1. So just by adding the reduce to the equal sign, we gave our calculator more ways to actually represent or calculate functions. Can we have a result come out without the point 0? Yes, that's actually something that we're going to figure out today as well. Hopefully, when we come that far, we will dive into NS number formatters for that, and we'll add some formatting to our numbers so that only if we need decimal places, the decimal places will be shown. So let me see, what else have we here? So let's do that. But I think before we do that, we will add our decimal separator. So we have this one button at our calculator which is supposed to add a comma or a dot, depending on where you live on the world, to this number. So hitting this like 2.5 shouldn't be 25 but 2.5, and we want to add that. So the first thing we need to do is in our view controller to add a new action, so which is called every time we hit this very button. And for that I just write it down, add IB action, which gives us the ability to have these dots here which can be connected to certain actions of control elements in our UI. And we call this function decimal separator, so that's right, touched. And here we go. Before I forget it, I have a habit of about forgetting connecting stuff after I edit it. I just click this button, hold the control key and drag it over to my view controller, and now I have all the different stuff I can connect it to. And here's our newly created IB action, and I tap it, and now this button fires this method. So, and now we have to do something here. And that's a little bit harder to explain. No, it's not actually harder to explain, but I have a little bit of a digression here. Maybe I leave this. Okay, I have an idea. Okay, that's good. So what we want to do is we want to add a new digit, and the digit is in our case the comma or the dot, depending on what region your iPhone is set to. So if you are living in the American or the UK kind of regions of the world, you are more likely to write a dot between the real or integer values and the floating point values of your number. And if you're living in like Germany, you do a little comma there. But I think the current simulator is set to the American style, so I will simply hard code that for now, but we will make that universal for the whole world in a second, as soon as we enter the realm of the number formatters. So we simply write add digit, and hopefully this works. We add a dot for the comma for the decimal places. And when I start this now, I type 5.2, and this looks like a decimal place. If I had equal, you see that the operand 5.2 up to it's pretty accurately 5.2. This little 2 at the end is because the data type we use to store floating point values can only store floating point values up to a certain amount of decimal places. That's called the number of significant decimals in the floating point value. Explaining this has a little bit to do with how CPUs calculate and store floating point values in memory and use this to calculate in the CPU. Explaining it more than that would be a little bit out of the scope of this session here. But if you want to read up on this, I encourage you to just look on to Wikipedia and Google for floating point number representation, and there you will find more information for this significant places or decimal places if you're really curious about that. So we just thinking about this value being exactly 5.2 for our purposes here. So this worked. So let's try another example of something that should not work by now. So if I just type the comma here, we just get this point. So I can add 0.5, which is exactly 0.5, but I really don't like how this looks. And if you're like me, you want to have the O, which is the default value of the display, to just be there and add a little dot behind it. And in order to achieve that, we have our the reason why this is not actually working right now is because our input string, which we are filling up with all the digits that we are typing in, is initialized with an empty value. So if you look here and at the add digit function, we see that if our empty string is empty, we just replacing the input string with the digit, which is in our case the dot. So this is why the display only shows the dot, which the showing of the text in the display is happening here. Just a little refresher on that. So what we want to do is basically pretty simple. So we want to change our input string to have a 0 in it when we hit the decimal separator touched. But we only want to do that if our input string is empty. And if that is the case, we want to set our input string to being 0 and then add the digit there. So if I run this now, and just starting by writing my decimal number here, I just write 0.5 equals, and now you see the right operand is actually stored. So going in here and adding plus 4.3 actually works. Minus 6.2 times 0.4 looks pretty good. Starlord91 asks a question, and that's actually pretty good because I want to dive into that after the next issue I want to face. So we're going to talk about this, Starlord, no worries. So let me just do a little commit to have our progress in the Git. So the first thing I want to commit is our newly added reduce function. So we add this, and we also add the part of the code where we have added the calculator reduce. I just see that this is, let's just try this and let me see if he's lets me just discard changes, don't commit. I just want to commit this one line here. That's possible in other programs, but it seems not to be possible in Xcode. At least I don't see how I can change the number of lines being... No. So let's use another program I use for Git repository management. And so it's a little digress here. I add existing local repository. I go to projects. Where are you? Here we go. Simple calculator and stream. Simple calculator. I think this one. Open. Here we go. So this is our other tool where we can our Git commits. So I want to commit this stuff from the calculator and only this line here. Stage selected lines. And now only this addition with that function is actually added to the Git. And I name this edit a reduce function to the calculator to reduce the current mathematical term to its value. And the second thing is the decimal touched thing. Edit the logic for adding decimal separators to the entered numbers. Okay. So before we start into looking into how we make this decimal stuff a little bit more universally applicable, we will dive into one more thing, and that is the all AC button or the all cancel button. And currently we're just setting this to 0, but we also have to, for it to work, to reset our calculator stack to being empty. So we do this and add a new mutating function, which we just call reset stack, and it's pretty simple. We call this reset stack, and this is just doing self stack equals this. So this will just simply throw out the current equation and put in nothing there. And another thing we gotta do is so first we call our reset stack, and then we will set the whole calculator back to its default values, which is not only that the display should say 0, but our input string should be empty, like we initialize it at the start of the program. So if I now go in and type some equation, 6 minus 5 equals this, and I want to start a new equation, I can just type AC, and this equals value 0 because the stack is empty. So if I go in like 5 plus 6 and I think, oh man, this is wrong, I can do 7 minus 3 and hit enter, and as you see, 7 minus 3 is the only stuff that is in the stack right now. The stuff that I wrote before I hit the AC button is gone. So that works as expected. So now we're coming after this commit, edit code for clearing the memory of the operator. So before we come to this here, we can now let's look at another thing. Add operand. Yeah, everything is good. Okay, so another thing that we can do now is to dive into making the separator sign universally, and likewise or more likely at the same turn add some better representation for our numbers, so getting rid of the decimal places that we currently don't need. So for that we need a number formatter, NS number formatter, and I just show you what this is. So we just look at the Apple documentation here, and we can see that a number formatter is basically a class which is converting between numeric values and their textual representations. So there are a lot of different settings for managing the amount of digits to be shown, and so basically what we need here is to use the function string from number when always we show something in our text label. So we will put this NS number, which can be a double value, we put this into this number formatter, configure it correctly so that the string that it generates from our number value that we put in there fits our requirements. So our requirements are that we only want to show a decimal separator and a decimal value if the value is bigger than 0 behind the decimal separator. So yeah, it's pretty useful actually. So let's get started by introducing our view controller to its very first and very own number formatter. So we will do this, we will create a new variable for our view controller, and we call this number formatter. And this is of type, or is initialized with a number formatter object. So like we have our own objects for the calculator, IRS provides you with a bunch of millions, okay, millions is perhaps a little bit too much, but thousands of other objects that we can use to use and reuse for our own purposes. So this viewDidLoad function is the optimal place to actually start initializing different objects and other components we use before we actually, when the app has started. So the viewDidLoad function actually tells us, okay, here we go, everything is ready for you to use. We have all the views that you need for your view controller set up in the memory. Now you can start configuring everything you need. So that's a good place to do our own configurations. So we go in and type self number formatter, and we want to show we have a number style, and this number style, it can have different values here. Like you see, currency accounting. So down here, if you go through this autocompletion, you actually see what it means. So if I go to currency, it says specifies a currency style format. For example, in the EN US POSIX locale, 1234.5678 is represented as US dollar 123457. So it actually does the rounding after the last shown digit. We want to have the decimal. So specifies the decimal style format. For example, 1234.5678 is represented as 1234.5678. So that looks exactly like what we want to have. And now Let's see if this already solves our problem with the dangling .0 at the end. So every time we are writing something into our display, we go through this display value here, writing display value double, and using this currently, this thing here, or more like string of new value, string of the new double, we write into this property and set it on our display label text. So this is the right spot to add our own functionality, or more like the number formatters functionality, to rewrite or represent our numeric value in a text form. So let me just see something here. Okay, so we go here and we will now add our number formatter, and the thing is working like this. So I just leave this down here as a comment just for reference for now. So display label text is equal to number formatter string from NS number. So our current input value is a double, which is not an NS number. NS number is a type that Apple uses to represent different or group different kind of numeric values, like integer values which don't have a decimal separator or fractional digits, like floating point or double values, which we're using here. Boolean can also be an NS number, which are basically a number which can only take on the values 0 and 1. And to have this all encapsulated in one type, so that we can just put it into the number formatter and he can figure out what is the best way to deal with it, we have to create our own NS number object for our new value. And this is pretty simple. We just call NS number and have now different initializer methods, and one of this is float literal, and this one takes a double and we put in the new value. So if you look at the old line of code and the new line of code, it's not that different. We just take the new value, put it into an NS number, and put this NS number into the number formatter, which returns a string which we can then display. So running this, typing in 5 plus 6 equals 11. So the number formatter automatically sees that we don't need a .0 there, and everything is now beautiful.
And reappeared.
Yeah, so Peter actually has a good point here. So that's next. So now we have the dangling 0 out of the way. We will now get over to the comma button or dot button, which should be adjusted depending on where in the world this calculator is used. And I just commit the recent changes here, and after that we will do this. Edit a number formatter to make the output deal or more humanly readable. So
His head disappeared.
we want to do two things here. First, we want to get rid of this hard-coded dot, which is not actually good, because if the iPhone is set to a different locale, which needs a comma there, this would actually not work. So we are pretty lucky, because the number formatter has a built-in property or variable we can query, and that is called decimal separator. And using this decimal separator will
His head disappeared.
give us the right decimal separator for the region we are in. Just have to check if that is actually there are couple yeah, it's decimal separator. So so this actually will, if I run this now, change nothing. Locale, I didn't understand. Okay, I will show you in a minute. So if I type in this, actually nothing changed for us, because now the right locale is used to determine the separator sign. So what is a locale? A locale is basically a definition of how the local representation for stuff looks like. So as you know that in Europe we mostly use the 24-hour way of determining time, whereas in other parts of the world, for instance in the US, you have the 12-hour AM PM way of specifying a certain time. And the locale is basically saying that for an iPhone which is set to a German locale, you should use the 24-hour representation for times. So if you write an app which has uses times a lot, times, you can query the locale and use a formatter, a date formatter, to show the current time in the right format. So if it's in the US, you have the 12 AM PM format. If it's in Europe, you get the 24-hour format. The same applies to our decimal separators. In different parts of the world, people use different symbols for determining that after that the fractional decimals are starting. In Germany it's a comma, in the US it's a dot. So the locale is determining, depending on what you set on your iPhone. If you go to the region settings, you can set it to whatever, US or Germany, you will get a different decimal separator there. Okay, so I think that is clear. So this gives us the decimal separator for the right locale. So now we can use this decimal separator to change the comma or dot on our button. So we want to have the right symbol on the decimal separator button according to where the person is. So for that we need an outlet to actually access our button from our view controller. For that, so we write IB outlet, which is a separator button, UI button, and we connect this other way around. So we go to our view controller, go to the connection settings, connections inspector, and see that we have write everything correctly, which I obviously did not. There's a typo. Going to our connections of the view controller, we have now the separator button here. We drag this to this button and now this is connected, and we can adjust it and modify it, customize it to our gusto in our viewDidLoad function. So self oh man, sorry for that. Separator. So button, title label text is equal to number formatter decimal separator. So this sets the title of our button, which is currently the comma, to be the decimal separator adjusted to the locale the app is currently used in, the region. And because I had a typo here, I need to reconnect this button, as you can see here. So you can see here I have this spirator button, which is actually wrong. And you see this little exclamation mark here. This means that the connection is broken. And here's the new one. So I delete this by clicking the X and going in here, pulling down, and now everything is connected rightly. And when I run this now, we should see a dot instead of a comma. And we don't. So that did not work. The question is why? Okay, so this is a little bit confusing because there are different ways of setting the label for a button, and one is to adjust the title label directly, which is not always working. So another way is to use the right method, which is set title for UI control state. I come to UI control state in a minute. So we put in set title decimal separator for the separator button, and the UI control state is basically telling us in what state the button is. A button can be in many states. It can be highlighted, it can be selected, I guess, it can be pushed down, it can be enabled or disabled, it can be normal, so just not touched. And you can actually have different titles for different states. So if it's disabled, you can write, okay, this one is disabled. If it's touched, you can say, okay, it's enough, let go of the button, or something like that. So, but we want to have simply the normal stuff. And if you don't set anything for the other states, it will always fall back to the title of the normal state. So let's go in and run again. And now we have a dot. So like you want it to be. So a way to test that for different regions is actually in Xcode. So you can go in here, in there where this is here, like next to the device you want to run it on, you can go in here, go and edit schemes, and there you can make settings for how Xcode should run your app when you debug it. And there are like different kinds of running the app. We use debug a lot, and there is this options tab here where you can set different locations or application regions. So I can go in here and set Germany to be the current region, which should, if I remember correctly, change the locale of the simulator, or at least the app for the app. So, and if you look now here, now that I run it with German locale, you see there's a comma. So if I do this, this is actually how we write decimals in Germany. So 2.5 plus 5 equals 0. So why is that not working? I think 5, 2 is actually adding the wrong digit. And that is a good question why it is. So let's figure that out. So the title of the number formatter decimal separator is totally correct. So this should be a comma, which is actually correct in Germany. So I think, let me just completely restart the app maybe there's a so sometimes the locales are not updating when you change them in Xcode completely, which is a little bit interesting because the button changed. No, he doesn't want it. So let's do a little bit of debug session and see what is going on here. If I add it to the add digit string and just make a breakpoint here, as soon as I tap on the separator button and the code reaches this place, it will break and I can inspect the values that are actually handed in. So doing this, now we are in the code and the program right at the spot where we want to inspect our values. And down here we have the separator, the inspector for our current values. And yeah, the digit is a comma, so that worked. So we put it in. And if we're writing, so the input string is actually built correctly. And I think the number formatter should actually, I know why. Okay, that's a good one. So there's another thing that we do. Every time we're using our input value, so the input value is automatically generated from the input string, and we use this double of input string, and if that works, we return the double or a 0. The problem here is that we don't want to a problem here is that the double function to create a double from a string is not using a localized number formatter. It always wants to have a value with a dot. So in order to work with this localized version, we can use a number formatter to get our double value. So what we can do is we call our number formatter and can call number from string. And this number from string, we input the input string. And this is actually, when you look at here, it's not always working, so it returns an optional. But if it works, we want the float value or the double value. And if that is not working, we return 0. So this is actually almost the same code as down here, but in this case we are using the number formatter. And if I run it now, we should now be able to parse our numbers even with the German comma sign. So should remove the breakpoint. 2,5 equals 2.5. So this works. Let's go back to our default settings here. Options, system region, close. Okay. What else? So now we have a pretty good thing going on here with our calculator. So it is actually almost completed and I'm almost done with the streaming time, but I think I will add one more thing here. Maybe 2 more things. So one issue, there is still one issue left, and that is the following. If I write really big numbers like this here, you see that it shrinks and it shrinks and it shrinks, and at some point you see there's only 3 dots, and these 3 dots actually preventing the user from seeing what he's typing. So that is not a good solution. So what we want to do is to have the best possible view for the user when he's writing big numbers. And there's this scientific way of writing numbers which we can use in our calculator to display really big, large numbers. And another thing that we want to do is when we write big numbers, we want to have separators for the thousands. So if I write 1 million, it's really hard to tell if I'm already at 1 million. So yeah, this is 1 million. But if there would be a little comma here and a little comma there, or respectively a dot in other countries, we could actually read that better. And this is pretty easy to do. After I did a little commit here for our separator button, localized, added localization for the separator button. So it's pretty easy to do. We can just go here in our number formatter and say, I think it shows, let me just check. It is, yeah, uses grouping separator. Uses grouping separator should be set to true. And the grouping separator is actually this little dot, respectively comma, at the thousands zero group. So if I write now 1 million, nothing happens. Okay, why is that? Because we are not using the number formatter in all places where we should need it. Maybe it is. This is interesting. Let me just check. What did I do when I first programmed this little calculator? Okay, so here it works. As soon as I hit the equal sign, it puts it in. But if I just adding digits, it is not. Why is that? Because this display text here is actually not using our number formatter. It's just changing the text that we are adding in. I think that was the case with the project I programmed before. I started streaming about it as well. But maybe there's a way to fix that. But if it's not really easy to fix, I would just leave it that way for now. Because there may be a problem elsewhere. So another way to do this is to set the display value and use the input value, but for that maybe the comma, adding a comma wouldn't work, and that's actually what I'm thinking here. Let me just think about this really quick if I find a good solution. So it has no function, just changes a look. Yes, this grouping is just changing the look, how we see the numbers. It's not actually changing anything about the real values, exactly. So I leave it this way for now, and just be okay with the result showing the grouping symbols, grouping separators, and we'll add I'll just throw it out for now, and maybe I will do a follow-up on that. Okay, so another thing that is a little bit annoying, like I showed you, if when we as we add really big numbers, there's three dots that cut off the last part of the number, and we don't want to have that, because that really limits the user to see what he's doing. And for that, I want to introduce another number formatter, which we are using after the number has a certain number of digits. So what we do is we add a private var scientific number formatter, which is itself just a regular number formatter, which is slightly differently set up. So it's just scientific number formatter dot number style to be scientific, and we want to use this value instead of this value every time our digits are more than 15. So what we do here is we first calculate our value, string value, by using our default number formatter, and if it's not actually giving us a string, because this can be failing and returning nil, we just assume that we have a string with 1 0 in there. So, and after that we will just check if the string count, so the number of letters in the string, is greater than 15, and will then use our scientific number formatter to give us a string for our NS number. So we can do this a little bit cleaner, do the NS number, put it in a variable from number, and put this in here for number, and if it's not bigger than 15, we remain using our normal number formatter and putting our string that we calculated up here in there. And so this should be able to fall back to a scientific view of numbers as soon as we hit a certain threshold. So as we do like 256 times 859 equals times 563 times 8745, and now you see we have fallen back into a scientific way of writing things. So that is working. Where it is not working is with me typing in numbers, because like I said, every time I add a digit, it is not actually using our number formatter. So going back to the issue we had before, we can try something here, which is just simply using the input value instead of the string and writing it to the display value. So every time we write something to the display value, we use the number formatter to do a text representation for that. So if we write input value equal to display value, we use our current input from our text, put it through the number formatter, put it into the display value, and put it back out. So this way we should be able to see the scientific numbers instantly as we're writing. So if I write this, so yeah, so this is working. As you can see, I write, and the scientific way is showing, and as well the grouping symbols are showing as well now. But there's a new problem, which is why I was a little bit hesitant to do this. It's if I tap on the decimal separator here, nothing happens, because 0 point something going through this number separator and going number formatter and going back removes the dot, because O dot is simply 0. If I keep on writing, that works. So in order for that to work, we have to do a little bit of a distinguishing what kind of digit is going in there. So because we want that to happen, I think the best way of doing that is actually to rewrite our decimal separator touched method, which is using the add digit stuff, and that is actually not helping, because in the case of the decimal sign, we want to use our input string, or better, we want to have, if the input string is empty, we want to have 0, and if it's not empty, the input string should be our current display label text, plus, so if it's empty we take a 0, if it's not empty we have a display label text, so everything that's currently shown in the display, and we then append input string, we append our number formatter display formatter and show all of this onto the display label. So that way we're circumventing the number formatter stuff just for that, but keeping the already formatted stuff that is shown in the display static, so that we can just add a little dot behind it. So let's see if that is working as expected. So if I tap the separator now, this works. If I go here, this works. If I go 1, 2, 3, 6, 5, 4, 7, I get the grouping symbols, 0.5. This works, which is actually not working. It's not it was converted. Why was it 0? Because 1, 2, 3, 4 equals 1, 1, 2, 3, 0. So why is it not actually, why is it reducing to 0? So there's something really interesting. So if I type 5 plus 3, it's always 0 now. So let's clear this. 5 plus 3, 8. Plus 3, 8. This sticks to 0. Okay, so this is working as expected, but I think that the problem here is when I have a number with this little commas in here. No, it works. Ah, okay. So there's a new problem here. So there's one last issue we gotta fix. So let me just do a little commit here. for adding an additional number formatter for there's one other thing I need to check right now before I commit this. So what happens when we start our calculator and add a scientific number to it? So when we write a really big number, is it actually being correctly translated to a value like this? Yeah, it is. So this works, everything is good. I was just wondering if the string with the E inside of it is actually going through the number formatter to be the right numerical value afterwards. So the last issue. Yeah, the new problem is the following. If I have a value 5, so we have one operand here. If I type in a new value and hit enter, equal, we now have a list of 2 operands, each side by side, 5 and 9. And 5 and 9 is not a valid equation. So that's why our evaluation function makes it 0. So what we want to happen is, if you have a 5, press equal, it should be 5. If I press 9 after that, it should be 9. So there should be no stuff going on here. And so let's see what is actually wrong. We have our function in the calculator that is called add. And the add function just appends a token, prints the stack, and returns the evaluated value. So, but now we have to check, we have to do a little bit more work here and check if the next value that we're adding, if our stack is not empty, is actually an operator. If it's not an operator, we have to replace the last value that we wrote before we appending the next step. So what we're going to do is we make a little bookkeeping here and ask our stack, hey stack, are you empty or are you not empty? Okay, and if you're not empty, tell me, is your last added this is something else actually. Let me just see. That's another issue that is handled here. So let's just, if the stack is not empty and we add a token, we have to check if the last thing that we added is actually an operator. If it's not, we will remove the last thing, because we can only add a operator to an operand. Makes sense, right? So after each operand has to be an operator. But another thing, before we tackle that problem, sorry for the little jumping here, before we tackle that, there's another thing that I have to show you, which is important to see for the next solution. When we are typing in our calculator, we're typing a plus, and after that a minus, we get actually operand addition subtraction, which is totally nonsense, but it still is figured out correctly. But if I type plus minus 3, at some point it's just losing itself. So plus minus 2 is 2 for some reason. So 5 addition subtraction 2 is actually removing itself or something, and that is not true. What I want to have here is when I change my mind about the last operator I tapped, so having like 5 and hitting the minus and was, oh fuck, sorry, oh this is actually supposed to be a plus, I just want to tap on the plus here and the subtraction to be replaced. So we do this right now, and we ask our stack if the stack, the last, is operator. And so this one here is a solution for both problems at one line. And let's look at this really closely, because this is actually solving the issue with the double numbers and with the double operators in one line of code. So we're asking if the stack is empty. Okay, if it's not empty, we check if the last is operator. So if we already have an operator there. So this is true if there's an operator. And then we check if the token, so the stuff we are adding, is an operator. So if we are having typing on plus and minus, the first thing will be true after we type the minus, and the second part will be true because the last thing in the stack is already an operator, the plus, and the new thing we're adding is the minus, which is an operator as well. Okay, so we remove the last and go on with our newly found operator, the minus. Okay, how's that helping with the numbers? So we know that numbers are operands, right? So if our last entry in the stack is not an operator but an operand, so a number, this is false. And if we are adding a new number, this is false as well. So this equal here is true, and we remove the last entry. So we're removing the last number. So I hope you understand that. It's a little bit tricky, but this is actually really helpful to use sometimes. So this is actually checking if the stuff that's in the stack is the same that it's coming in, and if it is the same kind of stuff, we remove what's already in there and replace it by appending the new stuff, and prior to that removing the old stuff. So that's actually what's happening here. So we don't have double entries in our list. So running this and now trying this 5 plus minus actually replaces the addition and subtraction. 3 equals 2. So this is clean, this is good, this works. So another thing we want to do was this: I type a 9 equal and I type a 5 equal, and now you see there's no 9 5. The 5 replaces the 9 beautifully. Minus 3 plus 5 times 9 minus 5. So this is actually working pretty good. I think it's everything I prepared for this calculator. There's a little bit more stuff we can do actually. So we could, for instance, select the last or highlight the last operator we selected. And we can add a C button and an AC button and just move them, just replace them. So if you have a calculator, the AC clears everything and the C just the last entered operand. So just removing this. And this is actually pretty simple to implement, I think. So, okay, let's do this real quick. So we have the all clear button. And we can, and I try this, I just haven't prepared that, so let's see. We need an outlet to our clear button. So we put this in here, connect this real quick to our view controller, the other way around. So like this, yeah, clear button. And we now want to change the label of our clear button depending if we already have typed in, if the input string is empty or not. Because if it's empty, we don't have some current number that we're typing in, but we know that we want to clear everything. So what we do every time we're setting the input string, we want to change the label of the clear button to either be an AC, or all clear, clearing everything, or just a C. So there's something that is called observers in Cocoa, which is you can put some code assigned to a property, and every time this changes, you can run this code. So you do this like this. You add a little did set block here, and every time this method or this variable is changed, we call this did set. And in here, we could simply go and write something like self dot clear button title, set title for control state to be either C or AC, depending on input string is empty, question mark. If it's empty, we have AC. If it's not empty, we have AC for the normal control state. So let's see if that is actually working. So this is an AC, I'm typing, now it's C. And when I hit the C, everything gets cleared and it's an AC again. So this is actually not the way this should work, because the function hasn't changed. We haven't changed our method down here, but we now see that the changing of the label, depending on what we type in, is working so far. So the all cancel button is should behave differently if we have a input string that's filled or an input string that's empty. So self dot input string is empty, we do what we would do when we will reset the calculator stack. Otherwise, so in all other cases, we will set the display to 0 and remove the input string. So this is all. This is all we need to implement this little function. So we just have a little condition which is saying, okay, only when the input string is already empty, then clear everything. So if I'm typing this now, this is clearing everything. If I go in here, 7, 8, 9 plus 1, 2, 3. Oh man, I thought this must be 1, 3, 2. I hit the C button once. and write 132 equal. And now you see that 789 is still in the stack, our operator is still in the stack, and the simple calculator operand 132 is actually the corrected one and put into the stack correctly. So that worked out as well. Okay, I think that is it. I think we have implemented a simple calculator in Swift, and there's a lot of small stuff you could add there, you can play around with. I will put this code up in the resources folder right after this, and if there aren't any questions left, please don't hesitate to write them now. I will be in the chat for the next couple of minutes, or add me on Skype to ask them. Write me a message on Live Edu. I'm happy to help, happy to answer. And yeah, all that's left is to say thank you for watching. Thank you for being part of this, and I hope you had a educational and a little bit fun time and learned a little bit about how to use Swift, how to build your UI, and how to actually think a little bit like a programmer to get this stuff into the right structure before you even start to write your code. So, if there's nothing else to say, it's just for me to say goodbye, and hopefully I see you soon with my next premium project or with my other live streams I do regularly here. It would be a pleasure to see you all again, and until then, see you next time. Have a great time, have a great day, whatever, morning, night, depending on where you are, and I hope to see you soon.